Good morning, Reddy sir. Sir, you have to unmute yourself there. Yes, 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 sir. No problem. You can try. Okay, okay. You have to unmute, sir. There.
Sir, you are able to hear me?
Yes, sir. I can hear you.
Now you are able to hear me?
Yes, sir. Yes, yes. I can hear you, sir. Hello, sir.
Yeah, I will try to share something and see whether I am able to, you are able to see.
Yes, sir. Yes, yes.
Are you able to see, sir?
Yes, sir. Your PPT.
Okay. Yeah, correct. I just come out then.
Okay.
Thank you.
Yes, sir. Yes. Sir, good morning.
Good morning, sir.
ಸರ್ ಇನ್ನೊಂದು 2 ನಿಮಿಷ ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣಲ್ವಾ?
Sir.
ಓಕೆ. Sir, we will start. Shall we start, sir?
Can I share the?
Yes, you can say, share. I'll introduce you to the participants and then you can start, sir.
Okay.
Okay. Good morning, one and all. Welcome to the day 5 of the International Skill Enhancement Program 2020 on programming and simulation software. It gives me an immense pleasure in introducing to you all the today's resource person, Dr. Siddhalingappa Gowda C. Biradar, very well known as Sidhu Biradar in the faculty fraternity. He is currently working as an associate professor at the Anand Sagar Academy of Technology and Management, Bengaluru, and he has 10 plus years of teaching experience, and he has 6 plus years of research experience. To read out the academic details, he completed his bachelor's of engineering in electronics and communication engineering from BLD's PG Halkatti Engineering College, Vijayapura. He completed his Master of Technology in Digital Communication and Networking Engineering from Gupta Institute of Technology, Belgavi. And he completed his doctoral degree in wireless communication and networking from the Anand Sagar College of Engineering under VTU, Belgavi. To read out his summary of achievements, he is a reviewer for International Journal of Creative Research Thoughts approved by UGC. He has guided more than 15 BTech or BE projects, and he has guided 6 plus MTech projects. He has published around the 12 plus international conference papers, research papers, and he has published his research findings in international journals, and that goes more than 6. He has also contributed to the national conferences with 4 papers published in the different national conferences. Apart from that, he is a certified Cisco CCNA routing and switching engineer, and also he has completed Cisco certified CCNP routing and switching. With this brief note, he has attended more than 30 workshops, and he has conducted more than 35 workshops for the students and the faculty members. With this brief note, I request Dr. Sidhu Biradar to take over and start the session. Thank you, sir. Sidhu sir, are you there? Sidhu sir, are you there? Sir, you are not audible, sir.
Hello, sir.
Sir, you can start, sir. You can start.
Okay. Okay, good morning all. Thank you for my introduction, Shan sir. Today we'll study NS2 and NS3. The main thing what we are going to study in today's session here is we'll be implementing certain papers related to NS2. At a note, I'll just glance over what is NS3, how can you run the program and all. You know that in each field, either you go for image processing, where in which MATLAB is used. If you go for signal processing, again MATLAB people use. If you go for VLSI, they use a cadence tool. Right. Different field have got their own software to work out. Even in a networking, we use a NS2 and NS3. This NS2 and NS3 tool, which is there, it's a research-oriented tool. Project student can do a project on this. Usually, B students, MTech student, or a PhD student. Try their own network with their own implementation of security thing and energy efficient and performance based routing and all. So most of the people who are there who are working on networking, they use NS2 and NS3 tool. But with respect to the industrial prospect, there where in which people don't use this tool much there, they use a packet tracer. That's one thing. This tool, it's a free version. You can download it and you can run in Windows 7 or in Windows 10 also, and even in a Ubuntu, any OS if you want, you can freely download it and run this software. Right? It's open source software. Right? Today, it will be most on hands-on session, so that you can go through this. At the end of the session, I will share you certain my YouTube videos, so that if you have missed any concept, you can go through that and you can simulate. This tool, at present, if you go for the VTU University, they are going to use for computer communication network lab. We have a computer communication network lab for CS department, EC department, telecommunication department, in even EC department. So most of the people, they either use NS2 or NCTN tool. Right? So this NS2 tool is very simple tool, freeware. You can work out with this tool easily. Here, the NS2 tool, which is there, it works with two programming language. One is a C++ and TCL script coding. Fine. TCL script coding is a front-end part wherein which whatever network you create, it is all written in a program format in terms of TCL script coding. TCL is nothing but tool command language. Right. Backend, if you want to access any parameter, functions, class, so you need to use the C++, right? So between TCL and C++, there is a OTCL present, which will have an interface between front end and back end, right? We'll see what is that, and when we simulate the network, right? And that this is what today's agenda, wherein which we'll study what is node structure, link, components of TCL script, example, how we can analyze the trace file and all. So this is a structure or a flow. We can say that how NS2 works. You know that there are different types of network in wireless communication: wired network, wireless network, sensor network. We manage mobile ad hoc network, and we have a VANET vehicular network. So these are the different types of network wherein which these networks can be created in and you can run these network in NS2. Right? There are certain softwares which can help you to create this type of network. I'll show you. Then once you create the network, you need to execute. So NS2 is like a whatever you create a network, it is going to execute it. Right? If there is if there is any parameter missing, it will throw the error, so that you can check that error and you can execute properly. Right? So this NS2 tool which is there, once if it executes the TCL script code, then it is going to give two output files, that is .nam and .tr. .nam is nothing but network animator, wherein which whatever the network which you have created, so that animation it is going to show. It's like from where the packet is going, from which node to which node, so which path it is following. whether the packet is getting dropped or not, whether it is reaching to a destination or not. That all you can see with the help of a NAM file, or we call it as a .nam file. Right? There is another file called as a .tr file. We usually say that it's a resultant file or a data file, wherein which whatever the simulation that takes place within the network, right? So that data is stored in that. Right. So with the help of that data, we are going to analyze the network performance. There are different types of performance parameters, like throughput is there, packet delivery ratio is there, latency is there, end-to-end delay is there, routing overhead is there. So these different parameters you can analyze with the help of that .tr file. So usually a researcher will mainly concentrate on TR file, wherein which he want to find the performance and all. Right. Once we start doing the network, we'll see that how to analyze this TR file and how to get the output of that. Fine. So this is a simple structure of working of NS2, wherein which first you give a TCL script file to NS2. So NS2 will execute that TCL script file. So if there is any error, it will throw the error. Right. So if it's free from error, then it will execute. It will give the two output file. One is NAM and trace file. So NAM is just used to see the animation. Trace file is just to analyze the performance of a network. Right. Next, if you see the introduction with respect to the NS2, it's a event packet level simulator, discrete event packet level simulator. So as I said, it's used for in a research purpose for doing projects and all, for BE projects, MTech projects. It's an open source tool. Front end we have a TCL script, back end we have a C++. You can simulate both wired and wireless network. So before starting this, this is a small network. I'll show you how to simulate this network. Here we have two nodes there, 0 and 1. So 0 is a source node and 1 is a destination node, right? So this, if you in this NS2, if you want to make a node as a source, so there you need to connect certain parameters like agents and application here. For example, here 0 node, I want to make it as an, I need to do here is, can use either two protocols like UDP and TCP, user datagram protocol, TCP, transmission control protocol. So these are the two protocols that are present in transportation layer. And there are certain application layer parameters like CBR and FTP. FTP is nothing but file transfer protocol, CBR constant bitrate thing. So as you know that in a communication, whatever the data is transmitted, it is transmitted through the 5 TCP IP model layers, that is our application layer, right? Transportation layer, network layer, data link layer, and physical layer. So the data has to travel from application layer to the physical layer. So same way here also the same concept it is followed here. Whenever you send any data, it is transmitted from application layer to the physical layer. Right? So if you want to create a network with respect to the any type of how many numbers you want nodes, you can use that. If you want to make a source, then you can use either UDP or TCP protocol. Right. And there is one condition here. If you want to use a UDP protocol, you should use a file traffic generator as CBR. Right. So usually we use in NS2 UDP with CBR connection, TCP with FTP. So the function of this CBR and FTP is to generate the packet. Because if you want to make any node as a source, then we need the source usually generate a packet and transmit, right? So FTP and CBR are the two parameters or agents, we call it as traffic agents. So these will generate a packet and it will give to the transportation layer, and these protocols which are there, UDP or TCP, it adds certain extra header data to it and then forward to the nearest node or to the destination, right? So this is one thing. So if you want to make any node as a source, you need to connect UDP. If you're connecting UDP, then you should connect to a CBR. If you're using a TCP protocol, then you have to connect to FTP. Right? So this UDP and TCP, these are the wireless, that is a connectionless and connection oriented protocol. And if you want to make any node as a destination, then here we can use again two agents like null and TCP sync. Right. So if you are using a UDP protocol, then you have to use an agent called as null here. If you are using a TCP protocol, then you have to use a TCP sync here. Right. So these are the two different cases that you need to follow in NS2 if you want to simulate a network. If you want to have a intermediate node, no need to use any connections here. So if you want to have a source, you can either use UDP, TCP, or along with this, you need a packet generator, that is CBR and FTP. And if you want to make a destination node, you can use a null for UDP and TCP sync for TCP. Right? In NS2, you can make any number of nodes as a source and any number of nodes as a destination. Right? So once we are going to simulate, we'll see that this is a basic thing what we see in NS2. And today I'll show you a 3-node program wherein which how to simulate these 3-node program, how to analyze and how to get the performance of it. Fine. I'll show you. Usually you can work with in Windows or you can work with in Ubuntu. Most of the people they use Ubuntu OS in order to, because it's when compared to other Linux OS, it's simple to work. Fine. Show you. So if you want to work with the NS2 in Ubuntu, no need to use any operating partition your hard disk. So it's you can use a VMware software. You can install that VMware software. After that, you can use a Ubuntu there. So present latest version 20.04, which is there Ubuntu. I have installed it. So there are certain videos available in internet how to install Ubuntu in VMware and how to install NS2.35. So latest version of NS2 is NS2.35. So from around 5 to 10 years, they have stopped the version of NS2. Now they are concentrating on NS3. So the last version is NS2.35. So it was stopped from long back, around 5 to 10 years. Right. Now people are using NS3. There are some people still they work on NS2. As I said, there are certain we can get a lot of data if you want to analyze the NS2 in the internet. It's not easy to get, as NS3 is it's a latest version software. Right. You don't have much data present there. In NS2, whatever you want to have, whatever you want to analyze, there are certain manuals are available, codes are available. We can go through that, and you can just take those as a reference, and you can work out in NS2. People usually, as I said, security, performance analysis, and energy efficient. In this field, people work using NS2. NS2 and NS3, the tool is not, there's no much difference between them. Whatever there is in NS2, it's there in NS3. But whatever is there in NS3, it's not there in NS2. Right? So if you want to work with a 4G LTE network, there are certain patches available. You can download that and you can add to this NS2.35. If you want to work on security, there are certain secured protocols, secured AODV protocol, secured dynamic source DSR protocols. You can download them. There are certain protocols available in the internet, and you can analyze the performance based on that. Right? So before starting with the execution process, today I'll tell you one interesting tool that we have in NS2 is NSG 2.1. So this NSG 2.1, which is there, it's a supporting tool that we use for NS 2.3. So if you want to run this NSG 2.1, it's a Java based software. You need to first install Java JDK. So you can check it in Google how to install Java JDK. So once if you install the Java, then this tool which is there, you can easily access it. Just right click and open with a Java. So this is one tool wherein which we can create a different network topology here, whichever you want. So most of the researchers, they use this tool. This tool will help you to create a network and it will generate code by itself, right? So the it's like a references for you to create a network. If you want to create a network, no need to write a program here, right? So you can just create a network and add certain parameters which are required for the communication of a data from source to destination. Then save this file and run this file in NS2 so that it will give two output files. Then you can analyze the performance and see the animation. Right?
Sir,
Hello, sir.
your screen is completely blank. Are you showing something or how is it?
No, no, sir. I'll share you.
Okay. Because the cursor is moving there, but no screen. It's completely blank screen.
Okay.
So I
Okay, sir. Now?
yeah, we can see this.
Okay, sir. I switched to Ubuntu OS. That's why.
Okay.
Okay. Here, as I said, this tool which is there, NSG 2.1, NSG is nothing but Network Simulator Generator. It is going to generate a code, TCL script code. Right. I'll show a simple program with respect to the wired as well as the wireless. So first I'll start with a wireless program. Just go to this scenario. You can click on a wireless. So here, this is like a screen, or we can call it as a slate, wherein which we insert certain nodes in this. So with this, we can connect from one node to another node. There are other things there, like it's wired is there. So you can choose wired if you want to have a wired network. Right. You can see that there are certain functions like single, vertical, horizontal chain, grid, random. So if you select a single, then you can have a single node there, right? Node, and again, if you have, you can use a vertical chains also. Here you can see number of nodes. You can use 10 nodes there, so that it can create 10 vertical nodes there. Then we have a horizontal chain here. You can select 7 there, and you can just click on this screen, wherein which it will give the number of nodes which you are requested. Right. So like this, you can create a node by either by horizontal or vertical. You can have a grid option there. You can also choose that grid function. You can see how many you want nodes, 5 by 5. You can see that this is a grid structure. I've seen some of the paper in which they create a different structure, right? So this is a 5 by 5 grid structure. Some people, they create 10 by 10, 20 by 20, 30 by 30, 40 by 40. 50 by 50, and they make one node, for example, n node as a source, and the last node which is there as a destination, right? Then they simulate with different routing protocols, and they analyze the performance and present the paper. So it's a very simple thing here. You can analyze the grid network. You can analyze the random network. I'll show you a simple thing. We'll start with the first wireless network. Right. So initially, I'll create 3 node network. You can see here. First, I'll choose a single. Right. So single indicates a single node. Here, when you select that and just click on this screen here, it will give you a node here, a node, and we have two values here, 439 and 505. So this is a x and y value of a node. Generally, wireless is nothing but it's a we measure the position of a node in x, y, z, right? So it's a 2D structure wherein which we have x value and y value, but not as a z. Z will be a 0 here. It's a two-dimensional structure, right? So 439 is a x value and y is nothing but a 505, which is there. It's a y value, right? So this is a node which is placed here, and if you see the gray color here, it's a range, we can say that, the communication range. So it is around 250 meters of range here. Each node which is there, it's of it will be having the a range of 250 meters. You can see there. So this is another node. Once if you select a single there, if you can click anywhere if you want, it will give you a node, right? So if a node which is there, for example, if you take this node, N node, you can see N6 and N1 which are there. So these nodes are within a node of range N node, right? So that's why they are getting connected here. If I take it away from N node, you can see that. So now the N6 node which is there, it's out of N0 node there. So it is that's why it is not got connected between N0 and N6 here. Right? And here in below each node N6 or N5, N4, N3, N2. So there is a number there. So those numbers will tell you at where actually these nodes are placed. Right? In this, I will just explain first with respect to 3 nodes. Later we'll see how to work with multiple nodes. Right. Here you can hold this node and you can move anywhere if you want. Right, you can see that. So as this N2 node which is there, it's connected to N0 as well as N1, because this node comes under the range of N0 and N1. You can see that this is a network which is of 3 nodes. Now I have connected 3 nodes there, N0, N1 and N3. So now I want to transfer a data from N0 to N2. So in order to transfer a data from N0 to N2, I need to create a source and destination. So in this example, I create a source with respect to N0. As I said, you can use any protocol, that is either TCP or UDP protocol. So here I'm using a TCP protocol. Then again, as I said, once if you use a TCP protocol, you need to use a FTP. Right? So FTP is a application layer parameter. Right? As you know that data is transmitted from application layer to physical layer in TCP/IP model. So FTP is a part of application layer. TCP is part of transportation layer. Right? So this connection will tell you that the node N0 is a source. Right? So whichever network you create in NS2, you need to, if you want to make a source, so this is a connection you need to follow. Right. So as I said, there is one more connection called as a UDP. Same thing here. You can select, go for agent. There UDP will be there. Just connect there and then connect to FTP, CBR. Sorry. So 2 cases are there. Making a node with respect to TCP and with respect to UDP. TCP if you are using, you have to use a FTP. If you are using a UDP, then you have to use a CBR, right? So this is a standard method of connection in NS2. Then if you want to make node as a destination, for example, here in this case, N2 node which is there, I'll make it as a destination. As I said previously, that if you want to make node as a destination, you need to connect again a agent here, right? As you know that I'm using a TCP protocol, that is transportation layer protocol. Here again I am using a TCP sync here. Both are TCP protocol which comes under application layer. Right. Then I am going to connect, I need to connect from TCP to sync here. So this completes the 3-node wireless network. Right. Whenever you want to send any data from one source to destination, you need to make source and destination connection. So this is a connection that you need to follow with respect to the TCP. Right. So no need to connect anything for the N1 node, that is intermediate node. Right. You can also move this node away from the network. Right. So there is one option here. You can right click on this. Just go to node and then just right click waypoint. Right. So you can move node at any point anywhere in a network. Right. For example, I'll see that here. Just a minute. Here you can see that at this point, you can see the position. There is a location here. You can see it will tell you what is the X and Y value of this position. Right? So you can see there, it will show you what is the exact location of this point. So anywhere you can get this value and make the node to move. Here around 700 to 100. So I will make this node to move away at 5 seconds at position as we have seen just now. It's 700 to 100. Right. Speed, with what speed you want to 10 milliseconds. Right. I'll just add here. Done. Right. So now we can, if you want, you can move this node away from network, or if you don't want to move any node, then you can put a hash comment there and you can simulate it. You'll see that, right? So this is a simple structure of a wireless scenario wherein which it consists of just 3 nodes. So this is a connection you need to follow for a wireless scenario in NS2. Either you connect for 10 nodes, 20 nodes, 100 nodes, 200 nodes, 500 nodes. If you want to make source, this should be there should be a connection with TCP, FTP, or UDP, CBR. If you want to have a destination, you can choose multiple destination and multiple source there, right? There is no any fixed thing here, but you should make a connection if you want to have a source, TCP, FTP, UDP, or you can use a CBR. Then here instead of sync, you can use a null in UDP. After all these things, then if you click on this TCL, it will generate a code by itself. Right. So you can see here, this is a code which is there. It is generated by this software Energian. Right. So from this we understand that no need to write any code by ourselves. Right. So this software itself will create a network. Just by connecting, you can just create a connection, add certain parameters like TCP, FTP, UDP, CBR, and it will give this code. This code which is there, it's written in TCL script, tool command language we call. So as I said, TCL it's a front-end programming language wherein which we use in NS2. Right. Whatever the network you create, so that should be written in a TCL script in NS2. But when you go for NS3, this code which is there, front end, there is no any TCL script. You can write a C++ or you can use a Python there. Right. So that is one main difference between NS2 and NS3. Like this network generator, there are certain animation like energy network creator. There are certain softwares are there even in NS3 also to create a network. Not to the higher extent, to the extent of NS2, simple 2-node connection you can make it. Right? So this is a program. I will tell you what this program is there. Now we have started with the network structure, then we got the code. So what happens if you have a code, but you don't have a network? How to understand it? Means it's a reverse process. Let's understand what is a reverse process we have here. You can see here, when you see this program here, there are certain parameters are there. These are the standard notations which are there. Usually it will be present in a wireless. Fine. I can see that the first thing which is there, channel, we are using a wireless channel. Fine. Then propagation, two-ray ground propagation, we have a physical connection is there, that is a wireless physical connection. That's what you can see, network interface type. We have a MAC, that is 80_11 IEEE standard, and there is a queue, that is whenever you want to send any data from one node to another node, so there will be a queuing technique present there between two nodes, which can reduce the drop of a packet. Like it is going to help like a flow control, right?
Sir, can you increase the font there?
Okay.
It's not visible.
Okay. 1 minute.
But devices, as you have heard, they need object access from a DNS provider, immediate website kind of website. So this has lots of use security challenges and it is a classic security. And then you have the IoT identification where you have lots of
Just a minute.
Sir, this is okay, sir. We can see.
Okay.
Yeah.
Fine. So these are the certain parameters, like channel, as I said, queuing technique, link layer we have, antenna we have, that is a omnidirectional antenna, and the queue length, which is a maximum packet queue length, it is of 50. I'll tell you what is this maximum length. Number of nodes here, we are using 3 nodes. Fine. The routing protocol, which is there, it's a AODB routing protocol. So can you see the screen, sir?
Yes, sir. Yes, we can see.
Fine. Here we have a X and Y value. X and Y, as I said, it's a dimension where we have placed within this X and Y value range, we have placed 3 nodes, right? That is the meaning of that. And when we are going to end this simulation, that is 10 seconds, there are certain other parameters like you can see here. Topology is there. You need to. These are standard notations in NS2, wherein which if you want to create any NS2 file, we need to use a set NS. It's like a defining a network simulator, a scheduler we can call it as. Set topology, we are using a flat grid network X and Y. We know we have defined here X value and Y value. And as I said, whenever you want to create any TCL script file, if you run those files, you are going to get two output, right? So one is with respect to NAM, the other is with respect to trace file. So if you want to generate a trace file, this is a command you need to follow, right? So set trace file open wireless.tr, and this is a command to create a trace file. Then as I said, we need to have a .nam file which will show the animation. This is a command. This is a command to create a NAM file. So wherein which you can see the animation, that is a packet transmission between source to destination or intermediate. So with respect to the other parameters, node is nothing but it's in a NS2 it's a blank thing, right? So it's a simple connection. If you want to have if you want to make node as a source, or if you want to make a wireless connection, wired connection, you need to add certain parameters. So these are the certain parameters that are added in a wireless network. Right. Same thing what we have defined here, value I can see there, value I, link layer. So what is this link layer? I'll tell you when we go through the PPT. And we have a MAC type, if Q, queuing length, that what we have defined. Q type is there, antenna, omnidirectional antenna we are going to use. Propagation, two-way down propagation, channel, agent, route trace, MAC trace, movement trace. This will see what is this when we are simulating. Right. As I said, we have used three nodes. These three nodes has got their own position value, X value, Y value, and Z value. You can see that N0 is the one which is having the X value of 179, Y is what 239. Z, as I said, it's a 0 here, right? So it's a two-dimensional structure. These nodes have only two values, X and Y. And this is a position N0 initial underscore node underscore PS N0. This is a one which will define the size of the node and its position. So here N0, N1, same as of N0, we have N1 as well as N2. So if you create around 20 node, 30 node, 40, 50, 100, 500. So same thing, just same parameters you can use, but the number will be different. The position of a node will be different, right? So that is a thing. As we know that in a structure which was there, I'll show you here also. You can connect. This is in Windows. You can also use in Windows there NSGN. Just download Java there and install JDK. After that, you can create a node. Just click here. Just a small 3-node creation, TCP connection, and TCP sync connection you have to do. And then FTP is there.
Sir, we are not seeing the screen. It's a blank screen.
Okay.
Yeah.
Same as we have seen in Linux, that is in Ubuntu. You can install this NSGN in Windows also. Here, if you want to run this software, again, as I said, you need to install Java JDK. So once if you install, just double click on NSG 2.1. You can see this animation or software wherein which you can create a network. Right. As I said, 3 nodes are created. TCP is there, FTP, and for a destination, I need to connect a sync. It's connected. So this is what the connection between 3 nodes there. Similarly, if you just click on this, as I said, it is going to show the TCL script. Same thing. Fine. You can see now that how actually the program it is defined. with respect to the code here, right? So we have a x value, y value, same here. Then as I said, you can go through this one. 1 minute. Fine. Right. Here we are connecting a TCP here, right? TCP is connected to node N0. You can see that same thing, whatever we made a connection there, it's written in a coded form, right? So TCP is connected to N0, set TCP, new TCP we have to create, and N0 is attached to TCP, attach agent N0 to TCP. Very simple language, you can understand the commands there in TCL script. And we have created a sync there, right? Set sync to the node 2. You can see that a new agent TCP sync attach agent N0 N2 to sync. And as you know that we have connected TCP and then TCP sync, that connection is again written in a coded form. So whatever you make any changes there in a NSG or any connections you make, that is written in a coding form here, right? So here, if you want to make source as a node as a source, then you are going to connect a TCP. That is, in order to do that, here in a programming, we write a code there, right? You can see that TCP node is connected to N node and it is attached. After that, we connect to a TCP sync that is at a destination. So that is connection is written in a coded form, right? And the packet size which is there is a 1500 byte. So this is a packet size of a source node that is transmitting a packet from source to destination, right? So this tells about TCP connection. Then after that, we have connected a FTP, which is an application layer protocol. So we call in a heading like application definition. So here you can see that FTP is connected to TCP, right? So we are set FTP is there. If there are multiple FTPs, then this parameter will change FTP 1, 2, 3 like that, right? So TCP is connected to FTP, as you know that I will show you. So you can see that TCP is connected to FTP. So this is written in terms of a program, right? Then again, when to start there is a called as FTP start and FTP stop. So what this defines here is when to start generating a packets. As I said, FTP is a protocol that will generate a packet and forward to the TCP or UDP protocol, right? So if you are using a TCP, then FTP is used. So this FTP will generate a packet at 1 second, right? And it stops at 9 seconds. But overall network simulation which is there, it is going to stop at 10 seconds that we have seen at initial, right? So this which is there, you can see that simulation time is in 10 seconds, right? So this time should be always greater when compared to this start and stop time, right? So that time which is there, it's a overall simulation end time. This is with respect to the packet generation and packet stop when it is going to stop. So one indicates the 1 second. At 1 second, FTP will start generating a packet and it is going to stop at 9 seconds, right? And again, the other things which are there, it's these are the procedures, termination process. We are using a trace file. You can see that we have defined a trace file there, NAND file variable, right? Show you. Right. So you can see that we have defined a trace file. You can see trace file we have defined. So these are the we call it as a global variables that are used in a TCL script. Right. Those we are going to end, that is we are going to close at the end of the session, right? End of the program. You can see that close the trace file, close the NAM file, NS, we have used NS simulator. So we call these three as a global variables, and at the end of the procedure we are going to close. And there is one more called as execute. Once if you execute this file, immediately you can see the animation, right? Then at the end again it's a exit process. It is going to stop, finish all the thing and halt the program. So this is what all about the wireless program, right? Once if you run this program, you can see the animation as well as the resultant file which is there. So this is all about three node network. I will show you now a wired network, how to create a wired network here. Fine, same thing, same whatever is there, same thing is there, even we have created in Windows. All the parameters which are there, they are all defined in a same format, right? So this is a three node network, right? If you want to create a wired network, how to do the connection again, right? So this we have seen. Then I'll close this one, and wired network, right? So here also in a wired network, you have an option to create multiple nodes like vertical chain, horizontal chain. You can see that grid network, right? 5x5 grid network. You can see that previously in a wireless network there was a range. You can see there was a gray color circle which was around a node there, right? But here we are not able to see that. This is because it's a wired connection, right? So here we are going to use a link, wired connection, wired link between one node to another, right? So you can see you have a horizontal chain. You can choose a horizontal network here, and we can choose a random. If you want to have a random connection, once I simulated with respect to the 10,000 nodes, right? So you can use 10,000 nodes also. You can see there. 5,000 nodes, 10,000 nodes, how much ever nodes you want, you can create here, right? You can see just if you click, have a random option and just click here, it is going to give a random number of nodes there, right? So in wireless, you can see that it looks something different when compared to random option, and here I will choose 500 nodes, right? So just click here. Take some time, 100 nodes. You can see that. So 500, I just double clicked it. You can see that around 10,000 nodes are there. You can see this connections. This is how they are randomly connected. I'll close this because the number of nodes are more here. It's getting stuck. I'll show you once again. Just around 100 nodes. I've seen some of the papers wherein which people create certain network. This is a wireless network with 100 nodes, right? So it depends how much nodes you want to create. You can make one node as a source and the other node as a destination, and simulate and calculate the performance, how the packets are transmitted with respect to different protocols also, right? This is the thing. So the wired network. So here also you can say that I'll select a node there and I'll just click on this the screen or a slate we call it as. So this I'm going to use 3 nodes here. Right. So I connect from here to here. So this is a connection between 2 nodes there. 3 nodes are used, N0, N1, N2. And I'm connecting duplex links between N0, N1 and N1 to N2, right? So there is a queuing type. You can see that there are different types of queuing techniques are there. So here we have a drop tail. A drop tail is one of the queuing technique which is used. So whenever you send any data packet from N0 to N1, so those data packets are transmitted through the queuing module. So what is that queuing module? How the data is transmitted? We are going to see later. I'll show you. And this link which is there, it's having a bandwidth of 100 Mbps. Right. And the propagation delay between 2 nodes, N0 to N1, it's of 10 milliseconds, and queue size which is there, it's of 50. Right. So what is queue size? I'll explain you. This is a connection with respect to 3 nodes in a wired network. As I said in wireless, same way here also, if you want to have a TCP connection, you can use a TCP here, right? Or else you can use a UDP. There is no doubt there. You can use UDP also. I'll show you UDP connection. Right. Then as I said, if you are using the UDP there, here you need to use a null here. Right. Then application, we have to use a CBR. So this is a connection with respect to UDP protocol. We have seen a TCP in wireless, and again at the end we need to connect these two here. If you want to connect these two, UDP and null, these are all these we call it as agents. There should be you should be always in an agent mode. Then only you can connect this here. Right. So this connection which is there, it's a 3-node connection. Now we can say that it's the same process with respect to wireless as well as wired. Only thing here is, here we have a link here. There it was a antenna we have used. We had a range of 250 meters. Right. Same again here. If you click on this link here, same again it is going to generate a code. I'll show you. It's not visible here. I'll show you in a Windows there. It will be practice, or you can go through this. Share 1 second. Fine. Right. I think you can see now. Fine. So wired network. It's visible, right? Right. Fine. See, right. N node is a just simple connection. N1, N2. Just select node single, then link. Just connect link here between 2 nodes. Fine. Then again agent. You can use UDP. Same connection. UDP. Null. And application layer, you should use CBR. Just you can't connect, as I said, if you want to connect these two, you should be in agent, because UDP and null are agent parameters. Now you can see it. So this is a connection. You can see select. I'll show you here. Fine. So this is a wired program. Right. You can see that same thing. You can come to know that there is a similarity between a wireless program as well as wired program. Initially, there in wireless, there was a simulation parameters like channel, physical layer, queuing length, protocol which you are using, X dimension, Y dimension. Right. So it's a wired network. So we don't have any other parameters other than stop. So this is a simulation parameter for with respect to the wired network. So stop value, stop, it indicates that it's at 10 seconds this wired network is going to stop. Right.
Sir,
So then,
sir, it is not visible. Yes, sir. Yes.
Okay. This is a wired network. Similarity is there between wired as well as wireless network. Here in this, when you see the simulation parameter, we have only stop here, set value stop 10. So 10 is nothing but 10 seconds it is going to stop. Overall simulation. Again, we have a create NS simulator. And again, we have trace file. So this is a command which is there that is used to create a trace file. Right. So there is another part of command which is there which will help you to create a NAM file. Right. So this is a scheduler. We call it as NS new simulator. That should be there in order to create a duplex link, and I can see that the bandwidth which is there between two node is 100 Mbps, and we have a delay that is 10 millisecond, and drop tail, which we call it as queuing module or a queuing technique. So this drop tail which is there, it holds around 50 packets. Means between two nodes there is a queuing model, or we generally call it as cubes. So it will hold around 50 packets. Right. This cube model is like it's a rack wherein which packets will be stored there. Right. To avoid the flow control. Right. Similarly, we are connected N1 to N2 connection, right? N0 to N1 and N2 to N1 to N2. So similarly, we have a bandwidth here 100 MB, 10 milliseconds, and drop tail around 50. Right. So if you want, you can change the bandwidth drop like a packet size, delay, and queuing size. Right. This is just a position where we are placed. That's not required. Here we have used UDP protocol. You are seeing previously TCP, now it's a UDP. Same process, just a slight name change is there. Instead of TCP, we have UDP, right? So N0 to UDP is connected to N0, and we have connected null there to create it as a destination. So N2 is attached to null, because we made a N2 as a destination, right? So in order to make a node as a destination in UDP, we are going to use a null. In TCP, we are going to use a TCP sink there, right? We have connected UDP and null. That is whatever, as I said previously, whatever we do the connection there in NSG, that is written in terms of code here, right? So packet size is there, and CBR. Previously we have seen FTP was there, now it's a CBR there, right? Then again we have a packet size here, data rate is there. Will share my screen with respect to Ubuntu. Fine. This is a code. Once after creating a network, just save your file. I have
Sir,
hello.
sir, I think there is some network issue from your side, sir.
Okay. 1 minute, sir. Sir. Sir, screen.
Yeah. हाँ sir.
So same program, whatever we have seen there. It's stored here in a folder called wireless shop program. Stored this. Once if I execute this file, I'm going to get two files which I set. So NAM as well as. So we'll see that how to execute that file. Right. So the extension should be there with respect to. So it's like a TCL script file. So it should be in .tcl format. So that's what here. I'll run the file here. I have stored that file which is there in a folder called as a workshop program. So I'll go to that folder cd space workshop program. So in this, see there are two files are there and one folder. The file which we have created with respect to wireless is wireless 3 dot. Right. So in order to run this file, so just I will use a command ns. Ns is nothing but network simulator space wireless. The file name what is there, and just put a enter there. Now you can see once if you run this file, it is going to give the two output files what I have said and explained in the presentation. You can see that these are the two files that are generated after execution of TCL script. So NS2 is used to execute TCL script file, right? So if there is any error there, and it will show the error, right? But it is not going to create any network there. Right? You can see here. I'll show what are these files. Before that, I'll show you the NAM connection. So these are the two node connections. You can see there. As I said, it will start at 1 second. This is a source node. It will start at 1 second and it will end at a 9 second. Right. You can see, you can speed up here. This is a dragger, we call it as. It will. You can see that there is a packet transmission from node 0 to node 2 here. Source 0 is a source. That is, packet is transmitted from 0 to node 2, that is destination. A small packet is being out of it, that is acknowledgement packet, we call it, right? That is transmitted from the node 2 to node 0. So this is, you can see there, wireless.net. This is a file which will help you to see the animation, just for animation. Right. You can see that this is going to end at, if you want to increase the speed, you can increase here. It is going to end at 9 seconds. You can see that at second it is going to stop. But overall network, when it is going to stop here, is at 10 seconds. Right. That's what we have seen. So this is animation which you can see the how the packets are transmitted from source to destination. It's just a usual visual representation. This is with respect to this file, right? And as I said, the file called this wireless .tr, right? So this is a file wherein which we call it as a resultant file, where results are stored, right? And see that this file, how to read this file here is, this file is read to column wise. The first column you can see that there is a S and R. So S indicates sent, sent from a particular node. You can see that there is a third column where we have a number 0, 1, 2, right? So 0, 1, but node number we call it as. So from node 2 is sent. Yes indicates the sent. So this, there are certain events like yes, R. Even we have a drop D also. If there is a packet is getting dropped, we have a D here. And the second column which is there, it's a time. It shows the time, at what period of time you are sending a packet, or at what period of time you are receiving the packet, right? So third column, as I said, you can see only three numbers are there, that is 0, 1 and 2. There are no other than 0, 1 and 2 because we have created only 3 nodes, right? Then fourth column which is there, this column there are certain parameters. You can see that there is a AGT is there, MAC is there, RT are there. So main parameters, so AGT, RTR and MAC, right? So what are these parameters? I'll show with respect to the PPT, you'll understand. Right. So before that, I'll complete this process. And again, we have a dotted line there, a dash dash. These indicates the flag notation. I'll show you what is that. Right. So 1 minute. There are other parameters like can see there TCP is there. 1540. This is a, there are even ACK acknowledgement packet we call, which will be of ACK. You can see that it's a 38 here, right? 38 bytes of size of that packet is 38 bytes, right? So whatever the packet sent from a source data packet, it will be of 1540, right? So we have defined the packet size in a program 1500 bytes. So 40 is the extra header that added to the packet and transmitted. And we know that RTES and CTS, these are the control packets which are used before connecting between source to destination. Right? So in order to avoid the hidden terminal problem, right? So ready to transfer the packet, clear to transfer a packet. How to read this format? I'll show you that. Format is that so that you can understand. So this is a format. You can see that there is a first column. As I said, it's an event form, right? Plus minus. It is when you are using a wired, we'll be having a plus.
Sir,
but
not
here
shared.
we have.
Sir, file not shared.
Sir.
It's not visible, sir. File.
Okay. Now, is it visible, sir?
No, sir. Sir, visible, sir, now.
Okay.
It's a doc file, no, sir.
This PPT, sir. Understanding the trace file format.
Okay, yes, yes.
Okay. Here, as I said, in order to read that trace file, you need to understand what is this format. First column, which is there, as I said, event. Second is a time. So if you are using a wired, we'll be having a from and to node, right? So packet type was there, TCP packet was there, ACK packet there. You can here is with respect to wireless, right? So we had a first column as an event where in which we had a SR, where will be D, as I said, D indicates where the packets has been that you can, and that second column will tell you the time. The third thing here is the parameters. As I said, there are certain parameters like AGT, RTR, LL, like link where FQ will be there, max will be there, FHQ, Y will be there. These are the different parameters are there. So whenever, as I said, whenever you transmit a packet from source to destination, the packet will travel from application layer to the physical layer, right? So if you are having a term called as AGT, means your packet is present at a application layer, right? So if you are having a parameter as means your packet will be present at a data link layer. You can see that this is a structure between and a channel. We have a physical layer. MAC comes with respect to the with respect to the data link layer, right? So we have a IFQ, right? Here we have a key there. And we have a routing, that is a network layer. We have an agent, that is an application layer, in which we have used a FTP and CVR there, right? So whatever you send a data transmitted through the all the TCP/IP layers there, right? So these layers, these parameters, they define the at which layer where the packets are there. Packets are there. If it RTR means the packet is at a routing layer. LGT means it tells that the packet is at application layer, right? So a MAC, it indicates that packet is at a data layer, right? Then have a dotted line, as I said, there is that indicates the flag. Then we have a sequence number. Next to that, there was a line which will tell you the sequence number. Then there are certain other things said. We have a protocol. We have parameters like ACK, acknowledgement. We had CTS, RTS. Right. So those are the things which are there. You can see that. I'll show you once again. Fine. Since I will run that file, this is a error warning there. In order to run this file, TR file, now I want to get a result of this file, means how many packets I have sent, how many packets I have received. So this is a file, TR file, we can say that, right? So resultant file. From this, I am going to get the output, right? So in order to do that, you can use a AWK script. This is a AWK script, which is a with the help of this script, you can calculate how many number of sent packets and how many received packets, right? So here, as I said, AGT is a application layer parameter. If the packet is AGT, then it is understood that packet is sent. If it is at a receiving layer, right, or in a AGT, then we say that packet is received at the receiving layer, right? And again, we can calculate the routing packet, how many packets are routed with the help of RTR, that is network routing layer. Right. I'll show you how to execute this file. Right. First, if you want to execute this file, first you should have a AWK-F. Then what is the file name of AWK? Right. Then we need to use a trace file, which we are going to calculate the value. Right. You can see that whatever the file that has executed .tcl. After that, I got two files, that is MAM and trace file, right? So using that trace file, I am going to get how many number sent packet and received packet. You can number of sent packets as well as the received packet. Here the sent packets is 257, received packet is 257. In the packet delivery ratio is 100. And NORL is nothing but normalized routing load. Even that is 0.02 and average end-to-end delay. It's a 300 here, right? 300 millisecond. So here, whatever the resultant file, which was a .tr file, with that file, you can calculate how many number of sent packets and received packets, right? And you can calculate other parameters like packet delivery ratio, end-to-end delay, normalized load. Right. There are different AWK scripts are there. In a simple C program, you can understand that. Right. So with respect to the TR file, you have to change the AWK script file. Right. That is a thing. What is the use of this output? How can I represent these values in my paper? As I said, at the end of the day, we will be implementing certain papers with respect to wired or wireless. I'll show you that. Right. So here, as one more thing, you know that this is one chart. We can go through this chart, where in which there are certain manual calculations also you can do if you don't want to use AW or like a graph and all. With the help of manual, you can do the calculation and show the result. So if you know the sent packet and received packet, you can calculate the delivery ratio. So received and sent, it will give the packet delivery ratio. Right. Then throughput also you can calculate. You can see that that is nothing but size of the packet. You know that we are going to have 1,000 5 as a data packet size, right? So that you can mention here end when you are going to end the simulation. Here we are considered 10 seconds, right? So that can write how many number of packet you have received. So based on that, you can calculate manually, right? So and you can put it in a graph wherein which show the result in a. I'll show you how to show the results in a graph here, right? That you can see that you can do it in a Excel there, wherein we just put values there, whatever you are going to do. I'll show you here. Right. So like this, you can add the values here and put a graph here, right? So just I will show you that I'll take 10 second, 20 second, 30 second, 40 second, and 50 second, right? Then here number of sent packet, right? Sent and received. So
Sir,
as you know,
screen is not visible, sir.
Okay.
Yes.
Okay. In Excel, you can do this. You can get a graph here. That is just 10, 20. I mentioned here 10, 20, 30, 40, 50. It's a simulation time with that. So initially, just now what we have executed, where in which we have chosen a time of 0 to 10 the simulation. We got how many packet received? 57 and 257 sent as well as 257 received. Right. Assume that at 20 seconds I get around 500 sent and 500. Similarly, 700. Right. So like this, you can get the number of packets sent. Right. So later you can put this in a graph. You can see here. The graph. You can see, you can put this graph into your paper and you can tell or compare what is the value, why, how many number of packets it is sent. There are different formats are there. You can use some different graphs there. You can see sent packets and received packet, right? So if you want to change the parameter, if you can change here, you can write whatever you want. Horizontal and here this will tell simulation time. So you can write here simulation time, can label whatever you want, right? Vertical you can write, you can write it packets. So like this, manually you can do it. You can put this graph in your paper and you can justify your answers, right? So this is, you can do it with respect to the, you can see that I will show example. This is one graph wherein which it explain you about the number of packet put, how much it has got, end-to-end delay graph. So this graph you can add it in a paper, right? This is what all about the node network. Shows some papers on this one, how to do it, how they are done in one of our papers, how to implement certain papers here. Here you can see that in this paper they are used AODB protocol, DSDB, and
Sir,
DSR.
it is not shared. Sir, it is not shared.
Visible?
No, sir, not yet. Yes, sir. Okay.
This is a paper in which they are used 3 different route protocol, ADB, DSDB. You can go through this paper. So I tell you how to implement this paper here, right? So they have created some network here, right? But use different protocols. And they have come up with a graph. You can see now. You can see that how they have created a graph, packet delivery ratio. Just now I showed you a table with that. If you know the sent packet and received packet, you can find out the how many number of packets received. That is packet delivery ratio. We have one more parameter called as packet. If you know received packet and sent packet, then you can come to know how many number of packets are lost there. That is sent minus received. If you calculate, you are going to get the number of packet lost. You can see that as just now we have seen, there is a pause time or assumption time we can. So they are calculated at 200 second, and they are calculated sent packet, received packet, and Excel sheet and got the graph here. So I'll show you how to do this one. Right. I think I'll share the screen. So to do that thing, same again. Go to NZ. Right. They are not mentioned how many number of ports they are using here. They have explained about the protocol. I'll show you how to do that, how to implement that paper. This thing, again, you go to wireless, right? I'll just insert few nodes there. Right. I will make this node as a source, that is a node TCP connection, and I will make FTP connection. Here I will make TCP connection, then I will connect here. So this is a network. If you can click on TCL, it is going to give the code here, right? So here you can see that there is an option here to use a protocol. Which protocol you right? In a parameter, you can see that default it is a DSDV. You can use AODV, right? So you can use a DSR, and you can use a DSDV. So these are the different routing protocols that sets the path between source and destination, right? In a program, there is much changes there. You can just, instead of AODV, you can just do the, you can have a DSR or DSDV, right? So we are going to get a different output based on different protocol technique, right? So AODV and DSR, these are the protocols that are used. So some people who are doing research on performance analysis, these protocols, AODV, DSDV, AOMDV, TORA is there, Leech protocol is there. So these are the different protocols that are there. You can use these protocol and simulate on a network. So based on their own technique, they have got their own technique, right? On-demand technique is there, right? Table-driven technique is there, right? So based on that, they are going to give the output. That is, they are going to have a connection, shortest path between source and destination, and transfer a data. So just by changing this routing protocol, we are going to get a different output here, right? So then you know that again use AWK script. Then calculate sent packet and received packet using AWK script, and go to the Excel where you can put the value and get the graph. So it's very simple to do here with respect to AODV, DSR, DSDV protocol. Right. I showed more papers how to implement. Then again, there is one more paper, like you can see same type of a paper. You can see AODV they are used, DSR, DSDV. They have come up with a graph. You can go through this graph here. Again, same parameters will be there, performance parameters, end-to-end delay is there. But in this, you can see there are a different number of nodes are there, right? So I think it's visible. The PPT, the PDF, which is I think it's visible you. End-to-end it is there. There is again packet delivery ratio graph is there. I showed you how to manually. What they have done here is they have created a different network, 5-node network, 10-node network, 15-node network, 20-node. They have increased the number of node network. Previously, we have seen there was simulation time, 10 seconds, 20 seconds, 30 seconds, right? But the protocols are same here. they have plotted a graph. You can use the Excel to plot the graph, and to get the values, you can use the AWK script, right? So this is one paper which you can implement it very easily. Right? So like this, there are many other papers. You can go through that. In this is one more type of a paper where in which you can that they have used a UDP connection and TCP connection, right? So it's a wired network, right? In a wired network, you can use a TCP connection as well as UDP connection. So what they are done here is they are used the UDP network, same network. They are used UDP protocol as well as the TCP protocol, right? So if you use a
Sir, it is
UDP
not
protocol,
visible.
okay. This is we can go through this paper where in which they are used wired network. This network which is there, it consists around 0 to 7 nodes, that is total 8 nodes are there. UDP connection is there, and they have made a TCP connection there, right? You can see that. It's very simple to create this network. I'll show you that how to create. And again, this is a graph that we get by the trace graph, we can call it as. Use Excel wherein which it's very easy to do it. I showed you how to do it, and they have come up with a conclusion that which protocol is the better. Either if it is P protocol or UDP protocol, that's what they are shown here. Bandwidth, change the bandwidth and calculated the performance. You can see here, I will show you how to create this kind of node. Right. Similar type of paper is there, I'll show you. You can see here, this is one more paper which is there. We can create with respect to it's a wired for congestion control algorithm paper. I'll show you how to create this network. This is where in which they have showed that this is a network. In some papers, they give the network and they give the parameters. Like you can see there, there is a bandwidth, right? Protocol which is a drop tail. So this network, I'll show you how to create that one. It's a wired one. Just I'll show this one minute. Fine, I think it's visible. So in this, we are using 5 nodes, that is S1, can see the 5 nodes are there, N0, N1, N2, N3, N4. So total 5 nodes. These nodes are used as a source in this paper. You can see S1 to S5. Right? So there is one intermediate node router that is there here. You can see there R1. Then R2 is there. We have 5 destinations here. Right. Then they are connected. A simple connection. They are just connect here to here. It's like bulb state structure. Just connection, simple connection. 5 node source nodes are there. 5 destination nodes are there. Okay. So this is a connection. Now I want to make node as a source, right? I can create a TCP connection. So just connect a TCP here. All these nodes are source nodes. Then if I am using a TCP, I need to use a FTP here. Right. So you can see here, I am using a FTP. Then again, I am going to use a TCP sync because I am using a TCP there at so. Just connect this TCP to sync. Right. So this is a connection. Just on TCL code is ready. Run it, and you can get how many number of send packet and receive packet. Then when you see the paper, what they are implemented or what output I got here is in this. I'll share you this paper. Every time I need to share. I think you can see it. Right? Share. So you can see that there is a connection. That is a bandwidth. You can change the bandwidth. 100 MB is there. There is a between R1 and R2. the bandwidth is 10 Mbps. Means the bandwidth is very less because they are implementing a version control method here. They are using a different routing, different queuing method. Well, it works with a first in first concept. Whenever the packet is transmitted from R to R2, first enters into the queue size which we have defined, queue box we call it as, and comes out, right? So there is a RED, random early detection. This is one more type of a queuing technique is used, and there is a ISEP-Q, right? So ISEP-Q is nothing but sophisticated pair queuing technique, right? So like these different types of queuing technique you can use, and you can get a different graph. For different model, we have a different graph here. You can see the RED, random early detection. So if you are using a random early detection, this is a graph. And here they are mentioned, you can see that second. So they are simulating with respect to 10 second, 20 second. And throughput here, you can see that with respect to throughput, they have plotted graph. SFQ is there. So different methods they are used, different protocols they are used, and they have come up with parameters. Same again, you can send packet. How many number of send packet when you are using the RED protocol or RED queuing technique. When you are using SFQ, what is the send packets and receive? If you subtract this, that is sent minus received, we'll get a lost packet, right? So with the help of that table which are shown in a PPT, so you can calculate the throughput, right? So what is a queuing length, maximum queuing length? This can also be calculated, right? So you can also choose different parameters, packet delivery ratio, right? So packet loss is there, loss packet is there, and again you can have a throughput is there here. You can have a latency is there, jitter we call it as, right? So different parameters you can, and compare these models, come out with the conclusion that which model is better. So this is paper like this. There are many other papers are there. You can just glance this paper. So same again, TCP they are used, TCP connection they are used here. Just share this one. Right, I think it's visible. Right. So in this paper they are used 6 nodes there, right? You can see in these 6 nodes they are used TCP connection. TCP is connected with, you can see that UDP is connected to CBR. See that they are varying the bandwidth. You can see initially between N1 to N2 it is 2 Mbps, N0 to N2 2 Mbps, between N2 to N3 it is 300 kbps. Right?
Sir, share
so
the paper.
They are varying.
Sir, it is not visible.
Oh. Now it's visible, right?
Yes, sir. Yes.
Right. So here different work is there, different parameters they are chosen. Delay, it is 10 millisecond delay, at 100 millisecond delay, propagation delay. Parameters you can vary and you can get the output. You can see here, this is with to the drop tail queue, this is with respect to the red queuing model, queuing technique. So here also they are used a different queuing module, right? As you know that they are the propagation delay, bandwidth, right? So they are using UDP protocol, TCP protocol. They are using a different model and they are getting an output with respect to that. You can see parameters that they are chosen graph here is throughput. Right? So I showed you how to do it, right? Then again we have a throughput here and here. So can also use the packet ratio for and delay end-to-end delay. And you can put a graph and tell that how many, you can see here in this TCP they are used UDP. When you are using a TCP protocol, how many number of packets you are sending, how many number of packets you are receiving, right? In case of drop tail, in case of red, right? So this scheduling or queuing technique we call it as. So with the help of these, you can get how many number of sent packet and received. You can graph and get a conclusion. So this is one thing see here. Then you see people ask how to do the energy, how to add energy module in a network. Right? So I will show you how to add a energy module in a network. One paper which I have done, which my student have done. So I will show you that. We'll just share this one. Right. So in this structure, this is again created from NSGN, where in which we have 5 nodes are there, N0, N1, N2, N3, N4. So these 5 nodes are connected to one common, that is node N1, that is a destination here. So N0, N2, they are connected to source, that is TCP and FTP connections are made. So it's a wireless connection, you can see here. All these sources which are there, N0, N2, N3, N4, they are commonly connected to N1 sync. Is there? I am going to add a energy module to this network, right? So how to add the energy module? What happens if I add the energy module? What is the output I am going to get? So people who are doing working on an energy efficient method, so they can understand this one better, and they can work out with this one, so that they can come up with a paper how the efficient the network is there. Right. So the new thing, we have seen the 3-node network, right? 1 minute, I'll share this one. I think it's shared now. Right. Here in this network, in this program, again, it's a 5-node. There is no much difference what we have seen in wireless. It's also a wireless with only 5 nodes. Same parameters is there. There is no any change. We have X value, Y value. Energy module. This is a new thing that is there. Right. So initial energy, it is 100 joules of energy, we can call it as. So all the 5 nodes which are there in a network, they are assigned with 100 joules of energy. Same again, we have the trace file, NAM file is there. These are the parameters need to define to a node. Right. There are certain extra other parameters. You can see energy module is defined, ideal power. So when the node is ideal, how much power it has to consume. Right. So sleep mode, receive power, transmit power. So these are the certain energy related parameters that you have to add in a program when you are doing the when you are calculating the energy or energy efficient performance calculation energy with respect to different protocol. If you are want to calculate the energy of a node, that all can be done using this energy module. Right. So these are the new things you need to add in a program. So if you add these parameters or the things, then you can get an output. Same again, we have a start time, stop time, FTP we are using. So when you execute this file, then you are going to get a TR file here. In this TR file, again, you can see there, the first column we have an event S and R. Second column is time there. Third column will define number. Fourth column will tell at which layer the packet. You can see AGT means the packet is at application layer of node 0. Right. So here it is a R means packet is there at a network layer, routing layer. Right. So MAC means packet is there at a data link layer. So this is what it will define. But when we are calculating performance, we consider AGT here. Because when we send a packet, when we receive a packet, the packet is sent from the application layer and packet is received the application layer. That's why we choose AGT as a when we are calculating the send packet and packet. And here you can initially energy 100. So at the end, what will be the energy? You can see how to. You can see this is a node 1. So the node 1 energy is 93.3 joules of energy. When you go for some other node like 4, what is the energy here? That is 91.88. So this you can put it in a graph, and you can check what is the energy and at what the energy is getting 0. There are certain nodes, those node energy becomes 0 there, right? Once can can see here come up with some graph also with the simulations that show you. One minute.
Sir, can you hear me? Sir? Auntie?
Just what I showed, right? So any doubts are there, you can share in a, hello sir? Hello?
Hello, sir. Hello, sir.
Sir, any doubts with respect to the participant? If there are any doubts, I can.
Yes. Participants, if you have any queries regarding NS2 or NS3, You can unmute yourself and ask the sir. Sir, I think they don't have any queries. I have a
Okay.
query.
Yes, tell me.
Just a minute. I'll show you one this thing.
Hello.
Yeah, yeah,
Yeah,
I'll
yeah,
show
I'll show
you.
you.
Sir, can
Sir,
you
can you
see
see
this?
this? 1 minute. Hello,
Sir,
hello, sir.
sir,
Ah, ah,
sir, if I have five nodes, A,
okay,
B, C, D, E,
okay,
and there is a connection from A to B, B to C, and C to D,
okay,
and there is a one more path from C to E, E to D.
okay.
Okay.
Ah,
In my simulation, can I make after some time, if suppose my simulation is going to run for around 1 minute, okay, if
ah,
can I make after some 10 minutes or 15 minutes, one of my node C or
sir.
E gets dead,
Ah,
okay,
that
and
you
can I
can
get
make,
a
sir.
result for that?
Yes, sir. You can get the result of each node. As I said in .tr file, all the data are present. You will come to know if you are using what period of time you are going to die. You can get it, and you can move the node away from that network so that it can disconnect the link that is there communicating between the source and destination. And you can also swap the node from one position to another position. That thing we can do it, sir.
Okay. And one more thing, till now, what I saw from your papers or this thing, there is one source node and one destination node.
Yes, sir.
Okay. Or there is one router where you have five sources and five destinations.
Sir.
They will go from one node to another node. If
Sir.
suppose I have a node which is acting both as a transmitter as well as a receiver,
Sir.
then how do you make that connection?
Sir, a node
Because
can be.
because
Huh.
in UDP, when you connect the UDP,
Right, sir.
your destination will be having a null.
Sir.
So how do you make that same node as a transmitter as well as a receiver?
Okay, sir. Sir, I'll show you this thing here in a diagram, where
Yeah,
in which just now one structure I showed with respect to the energy,
correct,
where in which center node was a destination surrounding where the source node. Right.
correct, correct.
1 minute, sir. I'll show you. The switching of Windows to Ubuntu is taking, or else I will show in Windows. Sir, it's not responding. I'll tell you.
Yes.
Right. For example, if I have a 3 node, right, at a source and 3 node at a destination, in between I have a 2 node, right?
Correct.
So 3 nodes which are there, source, I'll connect it as a TCP and FTP, and the other node I connect it as a TCP sync, right? So I connect from one node to another node, that is TCP to TCP sync. Fine. So now 3 nodes which are there here can communicate with the other 3 nodes at a destination. Now what I do here is I have already connected a destination node TCP sync as that. There again I will connect it as a TCP there again. And whatever the TCP sync, TCP connections which I made at source, there again I will connect a TCP sync. So then this destination becomes a source, and again those become a receiver. Right. So I can assign a time period, you know, that when to send a packet, when to stop it. Right. So start time and stop time, that you can assign. So first we can make a source node 0, 1, 2, 3 to sign, and destination node to receive. Then destination node we can assign certain time for that, and then send those packets from destination to source. So we can make a single node by connecting TCP and TCP sync separately to source as well as the destination.
Okay. Okay. Thank you.
So
Thank
it's
you.
okay. Okay. Then any other questions, sir?
I think the participant don't have any questions. They have understood everything. There is no question in the chat also. We can close now. Okay.
Okay, sir. Okay.
Yeah.
Okay, sir.
Thank
Thank
you,
you.
sir, for a very informative and research oriented information regarding the NS2 and NS3 along with the NSG 2.1. Thank you for the demo given, and hope all the participants will have a knowledge, and if they are handling some computer network related or wireless communication related courses, they will make use of this course and session, and they use it. Okay, sir. Thank you, sir, for a wonderful session. Participants, thank you, and we will resume it at
Okay, sir.
11:45
So if
for the next session.
okay, sir. So if
Yes.
anyone
Yeah. Sidhu, you can share your contact details in the chat box, sir.
okay, sir. Okay, I'll share. If anyone interested to do any project, or if they have got any doubt with respect to NS2 and NS3, they can contact me. I'll just share my details.
Sir, are you sharing the information?
Sir. It's getting stuck here. 1 minute.
You post it to everyone so that everyone will have a,
Okay, sir.
they can see it in their chat box.
stuck here. I'll share you my details, sir. Please forward them.
Yes, yes. I'll be sharing your
Sir,
biodata also along with the materials. If you can share the material, the presentation material or any other
okay, okay.
tutorials related to NS2, I'll be sharing it with all the participants
Sir,
after 27th. Okay.
okay, sir. I will share my PPT and whatever the program which you have done. In that PPT, I given there is my contact details and email ID.
Yes.
So they have any call me or
Yes, sir. Yes. Thank you. Sir, you can sign off if you want.
okay,
Otherwise, if you are
okay.
interested, you can continue with the next
So
session.
1 minute.
Yes, sir. Yes.
Uh, no, sir. 1 minute. I will share the detail.
Okay. Sir, I think there is a internet issue from your end because your video also getting disconnected in between. Sir, hello, hello. Hello, hello, hello.
Hello.
Hello, sir.
Hello.
Hello, sir.
Sir, shall I start presentation?
Sir, ready, sir. 5 minutes. It just got 5 minutes back. Just 5 minutes, sir. We will start, sir.
Dr. Prashant.
हाँ, sir.
Sir, shall I start the
Sir,
presentation?
sir,
Shall I?
sir. 2 minutes. 2 minutes, sir.
Okay. Yeah. Do I need to put the video on?
No, if you are comfortable, you can put it, sir. Otherwise,
Okay.
you can mute.
Okay.
I mean, stop the
Okay.
video.
Okay.
Sir, shall we start, sir? Sir? Ready, sir?
Yes, sir.
Shall we start?
Yeah, I am ready.
Okay. Good morning, participants and sir. I'm pleased. Hello.
Yeah, we are able to hear you.
Yes, sir. Just a minute, sir. It gives me. Hello. It gives me an immense pleasure. Hello. Yeah. It gives me an immense pleasure in introducing Professor C.V. Satyanarayana Reddy. Sir Reddy, sir, can you just mute it?
I'll just mute it.
Yes, sir,
Okay.
please. Okay, sir. Uh, Professor C.V. Satyanarayana Reddy, he is currently working as an associate professor in computer science and engineering department at School of Engineering, Dayanand Sagar University, Bengaluru. His areas of interest are IoT, the machine learning, deep learning, computer networks, cellular networks, and big data analytics. He worked in the domain of telecom, networking, big data, IoT, machine learning, RFID, neural networks, and deep learning. He has completed his Master of Science in Technology, Applied Electronics from Regional Engineering College. He completed his Master of Technology, Computer Technology, Indian Institute of Technology, Master of Business Administration in the specialization of marketing from Indira Gandhi Open University. He is a certified project management professional. He is a Scrum Master, a safe methodology, involved in achieving SEI level 5 certification for Motorola, IBM, and HP services.
SCR WN REC.
Participants, please mute yourself.
ಇದಂಗ ಇನ್ಸ್ಟಾಲ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಚಲೋ ಮಾಡ್ಬೇಕ.
Hello.
ಹಾ ಸಿಸ್ಕೋ ವೆಬ್ಎಕ್ಸ್ ಅದು ಆದ್ರೆ ಇಲ್ಲಿ ಆರ್ಟಿಫಿಷಿಯಲ್ ಇಂಟೆಲಿಜೆನ್ಸ್ ಅಂತ ಹೇಳ್ತಾರೆ ಇವರು. ಈಗ ಏನು ಆರ್ಟಿಫಿಷಿಯಲ್ ಇಂಟೆಲಿಜೆನ್ಸ್ ಚೆನ್ನಾಗಿದೆ.
Sir? He has worked for HP 17 years. He has worked for IBM for 5 years. He was working with Motorola for 3 years. He was working in the Department of Electronics, NIC for 4 years. And DCM Data Products 1 year. He has 30 plus years of experience in technology and management in satellite communication, data communication, cellular and telecommunication. Out of 30 years, he has worked on driving technology for 15 years and in the management position for 15 years. With this brief note, I request sir to continue with the session, sir.
Thank you, sir, and welcome all the people for this presentation. So today what I am planning to do is I am planning to basically give the exposure to all of you on the machine learning and deep learning, and I will also expose you what are the different tools available in the Python in order to do the machine learning and deep learning. And I will also show 1 or 2 practical experiments so that you will get the feel of hands-on experience on this area. But whenever you get the time, you can just practice these things offline whenever you have time. So that is the overall agenda for this. So whenever you have question, you can stop me. I can basically answer your questions. And the time is restricted. I cannot complete actually overall machine learning and deep learning in 2 hours. So whatever possible, I will try to cover. And if you are not understanding, please raise as many questions as possible so that we can understand each other. So what we are going to talk about today is we will basically talk about what is meant by artificial intelligence. As a part of the artificial intelligence, we are going to talk about the different areas. So the definition of the artificial intelligence is given like this. Artificial intelligence is an intelligence demonstrated by the machines in contrast to the natural intelligence displayed by the humans. Generally, as a humans, we have intelligence. If you can build a similar kind of intelligence in the machines, it is basically called artificial intelligence. That is the definition of the artificial intelligence. So today, as a part of this artificial intelligence, we are going to learn about the 2 areas. One is called machine learning and another one is called the deep learning. These are the 2 areas we try to understand. So what is meant by machine learning and what is meant by deep learning? What is meant by machine learning means here machine is nothing but the computer. Here machine is nothing but the computer. So how do you make the machine to learn so that the machine can take the decisions similar to the human beings? That is the main purpose of this machine learning. So the deep learning is the subset of the machine learning. So in the deep learning, what we do is between the input and output. See, actually, this machine learning and deep learning is extremely good for the electronics people as compared to the computer science people, because electronics people have got a lot of experience on signals and systems, network theory and all that. The overall machine learning and deep learning is nothing but signals and systems only. So if you take any system, you have input, the system will do the processing, it will give an output. That is the general function of any of the systems. So if you take any system, we give an input, the system will do processing and it will give an output. So in the machine learning also same thing happens. So the machine learning can be simulated as a system only. So as you know, any system will have an input, it will do processing and it will give an output. I'll give one small example for the machine learning. Suppose if you take an example of some small function f of x is equal to 2x. So this is basically f of x is equal to 2x is an algorithm. We have written a program for f of x is equal to 2x. So if you give x is equal to 1 as an input, you will get output as a 2. If you give input as 2, you will get output as 4. If you get input as 3, you will get output as 6. Am I correct? So in any machine learning, we have input, we have a system which will do the processing, which is nothing but f of x is equal to 2x, and we have an output. Okay, these are the three important parameters you have to learn as a part of the machine learning: input, processing engine, and the output. So here the processing engine is nothing but f of x is equal to 2x, whereas the inputs we are giving different inputs like 1, 2, 3, 4, and corresponding to the inputs, the function will calculate the output and give you the output. Is it clear? These are the main important concept you have to pick up before going further on the machine learning on the software. So what I'm telling is the machine learning can be simulated as a system only. Any system will take input, it will do processing, it will give an output. So I have taken the processing engine as an f of x is equal to 2x. For that, inputs can be given as 1, 2, 3, 4, 5, and the output can be 2, 4, 6, 8, 10 like that. Okay. So that is, so what are the main components of the artificial intelligence here is machine learning and deep learning. And the artificial intelligence can be applied in different areas. It can be used in the machine learning, it can be used in the cognitive computing, or it can be used in the export systems, or in the computer vision, or robotics, or speech processing, or neural networks, or natural language processing. These are the different branches of the artificial intelligence. We can simulate this artificial intelligence with respect to the human being. Suppose if you take any human being, we try to see something, we do processing of those images, and we'll take some action. That is basically called computer vision. Computer vision. And if you see human being, inside the brain, we have a lot of neurons. Simulating those neurons and taking action will be done by what is called cognitive computing. Can I request all the people to put their systems on the mute, please? Thank you. So the cognitive computing is nothing but simulating the neurons in our brain inside the computer is called cognitive computing. And we talk to the people depending upon the interactions. We try to understand the people's speech and try to take an actions. That is called speech recognition. And the natural language processing means we'll try to read and write. The read and write of the human beings can be compared with the natural language processing. And as a human being, we also interact with the environment and we try to take actions by interacting with the environment. That branch of the AI is called robotics. So these are the different areas of artificial intelligence. So I already talked about what is meant by machine learning. Machine learning means making the machines to learn, And we'll try to understand how do you make these machines to learn using the Python slowly. Okay. Are you able to see this diagram? this diagram should give you the overall feel of machine learning very, very clearly. Suppose if you take an ordinary computer, I have written a program which will find out the area of the triangle. Area of the triangle is half into base into height. Am I correct? I have written a program which will find out the area of the triangle. So if I give input as base and height, it will calculate the area and you will get the output. So the way the regular computer will work is, you have a computer where you have written a program, you give input to the program, it will give the output. That is how the regular computer program will work. Can you please mute your systems, please? So the way the regular computer program will work is, you write the program in the computer, you give input, it will take the input, it will calculate using that program, it will give the output. Whereas in the machine learning, what it happens is, you give input and output, it will calculate the algorithm. Please understand, this is the crux of the machine learning. So if you take regular computer program, suppose I have written a program y is equal to 2x. I give x is equal to 1, output you will get y is equal to 2. If I give input x is equal to 2, I'll get output is equal to 4. So the regular computer program will take input, it will calculate the output and give it to you. Whereas in the machine learning, you give input and output, it will calculate the y is equal to 2x automatically. This is the crux of the machine learning. So in the machine learning, in most of the machine learning algorithms, what happens is, you give input data, you give output data, it will calculate the algorithm automatically. So when you wanted to write any programs in machine learning, you need not write any program at all. Just you give input, just you give output, it will automatically give you the program. Is it clear? This is the crux of the machine learning. Unless you understand this funda, we cannot go further. I wanted to repeat once again. If you take the regular computer programming, what happens is, you write a program, the program will take an input, it will calculate the output. That is how the regular computer program will work. Whereas in the machine learning context, what happens is, you give input, you give output, it will calculate the program automatically. So the output you get in the machine learning is a program. Is this clear? This is the crux of the machine learning. So we'll go further now. I wanted to explain once again what is meant by machine learning with this small example. Suppose if I take an equation f of x is equal to 2x plus 1, if I put x is equal to 2, f of x is equal to, you will get 5. If I put x is equal to 3, you will get 7, 4, 9, 5, 11. Okay. So what I am telling you in the machine learning is, suppose if you give this input 2 and 5, it will automatically calculate the equation 2x plus 1. That is the crux of the machine learning. Whereas in the regular computer programming, you give x is equal to 2, it will calculate the 5, output as a 5. Whereas in the machine learning, you give input and output, it will automatically calculate the equation f of x is equal to 2x plus 1. Okay. So that is a funda you need to just, you should not forget as a part of the machine learning. Okay. So now slowly I wanted to introduce the concepts of the machine learning. What we understood about the machine learning is, machine learning is nothing but making the machines to learn. How do you make the machines to learn is, in the regular computer programming, what happens is, you give input to some program, it will give an output. Where in the machine learning, you give input and output to machine learning algorithm, it will automatically give you the program. So you need not write any programs in the machine learning. Just you take the input data, you take output data, you give it to the machine learning algorithm, it will automatically create a program for you. And that program you can use it for predicting any other value. Is this clear? What is the difference between the regular programming versus the machine learning program? Hope it is clear. Okay. Now I will just go into the fundamentals of what are the different ways the machines can do learning. Suppose if you take a human being, when you are born, we don't have anything in the brain. Am I correct? We will try to learn a lot of things from the mother. We try to learn a lot of things from the brothers and sisters or from anybody else. So similar way, the machines also will learn it. There are three ways the machines will learn. One is called supervised learning, and another one is called unsupervised learning, and third one is called reinforcement learning. These are the three ways human beings also will learn, and these are the three ways the machines also will learn. The first one is called supervised learning, the second one is called unsupervised learning, and the third one is called reinforcement learning. Okay, these are the three different ways the machines will learn. So what is meant by supervised learning? Supervised means teacher. Teacher teaching to students, the students will learn. That is called supervised learning. Supervised learning means somebody will teach you, you learn. That is called supervised learning. Nobody will teach you, you learn. That is called unsupervised learning. So that is the difference between the supervised learning and unsupervised learning. Supervised learning means, supervisor means teacher. Teacher will teach you something. Teacher will teach you saying that 2 1 ja 2, 2 2 ja 4, 2 3 ja 6, 2 4 ja 8. Like that teacher will teach you, you will learn. That is called supervised learning. But there are some cases where you try to learn on your own. When you try to learn something on your own, it is called unsupervised learning. Unsupervised means there is no teacher. You try to learn something on your own is called unsupervised learning. The third technique is called reinforcement learning. Reinforcement learning, that is the third technique. Reinforcement learning means you make somebody to learn forcefully, they learn. Okay? The example for reinforcement learning is, suppose there is a student, the student has to study from evening 5 to 7. The mother will tell students saying that daily after coming from the college, you have to study from evening 5 to 7. If you study 5 to 7, you will get a food. If you don't study, you don't get food. That is called reinforcement learning. Reinforcement learning means rewards and penalties. These are the two words you have to remember. Reinforcement learning means rewards and penalties. Means if you are asked to do some work, if you do that work, you get a reward. If you don't do that work, you will get a penalty. That is called reinforcement learning. Suppose you are going on scooter, if there is a red light, if you stop, reward. If you cross the red light, you will get a penalty. That is the example for the reinforcement learning. So these are the three important learnings in the machine learning. One is called supervised learning. The another one is called unsupervised learning. The third one is called reinforcement learning. So what I told you, supervised learning is the teacher will teach you something, you learn. That is called supervised learning. If you learn something on your own without teacher, it's called unsupervised learning. Reinforcement learning means you make somebody to learn something. If they learn, they will get reward. If they don't do it, they will get penalty. Okay? So these are the three important learnings of the machine learning. Even as a human beings, we try to learn in these three modes only: supervised, unsupervised, reinforcement learning. Okay? I hope you understood what is meant by machine learning. What is the difference between the machine learning and the regular computer learning? And now we will try to go a little in depth of these things. I just wanted to introduce you to the terminology that is used in the machine learning. Okay. Suppose if you take this algorithm, f of x is equal to 2x plus 1. If I put x is equal to 2, f of x is equal to 5, x is equal to 3, 7, 4, 9, 5, 11. So in machine learning, there are some terminologies you need to understand. These three terminologies you need to understand. First one is called feature. Next one is called label. The third one is called model. These three things should be very, very clear for you. Feature, label, model. These are the three terminologies used in the machine learning. Features, labels, and model. So if you take this example, f of x is equal to 2x plus 1, all the inputs like x is equal to 2, x is equal to 3, x is equal to 4, x is equal to 5, these are called features. These are called features. If you take output 5, 7, 9, 11, those are called labels. and f of x is equal to 2x plus 1 is called model. Be clear about these things. So we are basically talking about what is meant by feature, what is meant by label, what is meant by model in machine learning. The features are nothing but inputs that will be given to any function. The labels are nothing but the outputs. The equation itself is called the model. These three terminologies you need to understand. What is meant by feature, what is meant by label, what is meant by model. Okay? Features are inputs, labels are outputs. The function is called model. Is it clear? Okay, so we basically covered now what is the difference between the machine learning and computer programming. We also covered about what is meant by machine learning. We also covered what is meant by supervised learning, what is unsupervised learning, what is reinforcement learning. And also so far we covered in the machine learning, there are three terminologies you need to understand. That is nothing but what is meant by feature, what is meant by label, what is meant by model. The feature is nothing but the input, the label is nothing but the output, and the model is nothing but the function. F of x is equal to 2x plus 1. That is what we have covered so far. Okay. Now, what I wanted to ask you is very simple question. Suppose I have given the equation f of x is equal to 2x plus 1. So for the machine learning algorithm, what we give is, we give input and output like 2, 5, 3, 7, 4, 9, 5, 11. These are the inputs and outputs we will give it to the machine learning algorithm. Once we give this input and output, it will automatically build this equation called f of x is equal to 2x plus 1. That is called model. So in machine learning, you give input and output, it will build the model automatically. So in the machine learning, you give input and output, it will build the function automatically. But what is the use of doing all these things? That is the question you need to ask. Why are we doing all these things? So in most of the real-time situations, we know the input, we know the output. Sometimes we need to build the system. This is basically called system synthesis. Okay, you have system analysis, system modeling, and system synthesis. If you have basically studied signals and systems, you will understand this terminology very well. So what we do in the machine learning is system synthesis. Means if you give input and output, it will automatically build a model. What is the use of building that model is, if you give any input, suppose if I ask x is equal to 7, since you know this model is 2x plus 1, just you put 2, 7 is 14 plus 1, 15, you will automatically predict the value. That is how this machine learning will be used. Is it clear whatever I am talking? Are you able to get it? I wanted to understand now, because before going in depth, I wanted to have these basics very clear. What is meant by supervised learning? What is unsupervised learning? What is reinforcement learning? What are features? What are labels? What is model? How are you giving features and labels to the machine learning algorithm so that it will build the model automatically? And using that model, if you give any input, it can predict the output very easily. So these are the basics of the machine learning. I want to know whether you understood or not before going little deep into the machine learning and deep learning. Is it clear? Any questions, please? Any questions? Can I move forward? Are you able to understand?
Sir, participants are putting in the chat box that they are understanding it. You can go ahead with the session.
Okay, thank you very much. Okay, very good. So this is what I basically told you. So what I basically told you is, so far, the purpose of the machine learning is, in machine learning you give the input and output, it will build the model automatically. Once you have the model ready, if you give any input, it can predict the output easily. That is the main use of machine learning. So actually, if you basically take big data analytics, there are three areas called PPDD. PPDD. PP means predictive analytics, prescriptive analytics, descriptive analytics, diagnostic analytics. 4 areas are there. These 4 areas are used extensively in the IoT environment, that is Internet of Things environment. PPDD, predictive analytics, prescriptive analytics, descriptive analytics, diagnostic analytics. So machine learning is used thoroughly in the predictive analytics. Means if you wanted to do the prediction, it can be used. So this is how the supervised learning will look like. Somebody is putting some comment. Okay. I don't have the slide for that predictive, prescriptive, diagnostic and descriptive analytics. Just I have given you an example. Our aim is to understand more about machine learning and deep learning and how to use Python for doing that. That is our main aim. Maybe in the next session we can go little deep into that. Okay. What is meant by supervised learning? I told you is supervised means teacher teaching somebody, then they learn. It's called supervised learning. So the supervised learning model will look like this. You will have a features, which is nothing but input. You have the labels, it's an output. Then the model will be built automatically. So if you give features and labels, automatically the model will be built. So I just wanted to tell you one thing. Whenever you have a data where somebody has given you the input data and output data, then the algorithm you have to use, the machine learning algorithm you have to use is a supervised learning algorithm. Okay. So whenever you have inputs and outputs given to you, you need to build a model, then you basically use the supervised learning model. So I just wanted to give one more small example for this. Suppose you take a pen. So the pen has got some features. It will have a refill. It will have some mechanism to put the refill down and up, and it will basically look straight. So if all these features are there, we basically label this as a pen. That is what is meant by labeling. Means if these features are there, you call this, you label this as a pen. If you take basically the goggle spectacles, so it needs to have two glasses. It needs to have something to wear it on the ears. If these features are there, you label this as a spectacle. That is what is meant by features and labels and model. Okay. So when somebody tells supervised learning means, what should come in your mind is, in supervised learning, you need to know the inputs, you need to know the outputs. You give this input and output to the machine learning algorithm, which we are going to discuss later. You give input and output to the machine learning algorithm, automatically it will build a model, and that model can be used in future for predicting anything. If you give input, it can predict the output easily. That is what is meant by supervised learning. Small example, there is a small guy. So we basically told this guy, okay, these are the features are there, this is called an apple. And these are the features are there, this is called a banana. This is how, so in the supervised learning, first what you have to do is, you have to train this boy saying that these are the features. If these features are there, you call this as a apple. And these are the features. If these features are there, you call this as a banana. First, you need to train the guy. Once the training is done, then you show banana. This guy will try to compare. Okay, these are the features are there, and it is called banana. That is how the supervised learning will work. So in the supervised learning, first you need to train the system with the features and the labels. Features means this, if you take the apple will be round, it will have the curves, it will have a red color. If these features are there, you label this as an apple. And these features are there, you label this as a banana. First you need to train this boy with the features and labels. Then once if you give any new item, like if you show him this banana, immediately he will tell this is a banana. That is what is called supervised learning. Okay. So what I basically told you earlier is, in supervised learning, you basically need to give the features, you need to give the labels, then it will build a model. Then if you give any features, automatically it will basically tell you output called label. So this is the crux of supervised learning. So whenever you want to write any programs, or whenever you want to use supervised machine learning algorithm, what you need to understand is, whenever you have input and output available, you give that input and output to the machine learning algorithm, it will build a model. Once the model is nothing but an equation or anything, once the model is ready, if you give any input, which is a feature, it will automatically predict the output, which is called label. So this diagram will give you the crux of what is meant by supervised learning. Okay. I'll move on because we don't have enough time. So, what is meant by unsupervised learning? What I told you earlier about the unsupervised learning is, unsupervised means no teacher. Learning something on your own is called unsupervised learning. So, in unsupervised learning, you will have only features. There are no labels at all. In supervised learning, you have features and you have labels, then you build a model. Whereas in unsupervised learning, there are no labels. It will have only features. So that is basically called unsupervised learning. Unsupervised learning. So a small example. So supervised learning means there is a teacher teaching to the students. 1 plus 1 is equal to 1, 0. It's a binary number selection. In the unsupervised learning, there is no teacher. The student himself will learn herself. 1 plus 1 is equal to 1, 0. That is what is meant by unsupervised learning. Example for unsupervised learning, I am giving you one more example. You see, in the unsupervised learning, there are no labels. It's only features. So suppose you basically, in the unsupervised learning, what happens is, suppose if you give apples, bananas to the kid, all the apples will be put inside one basket, all the bananas will be put inside another basket. But the kid doesn't know the whatever is there in the basket is an apple or banana. There is no labeling. Only the items of similar type will be put in one basket. That is called unsupervised learning. Unsupervised learning means clustering, means items of similar type will be put it in one basket. That's all is meant by unsupervised learning. Hope it is clear what is meant by supervised learning and unsupervised learning. So when somebody talks supervised learning, you need to have input, you need to have an output, you build a model. Then if you give any input, you will get an output. That is called supervised learning. Whereas in the unsupervised learning, only you give input, taking those inputs, you basically cluster those inputs depending upon the characteristics into some buckets. That is called unsupervised learning.
Ready, sir?
Suppose if I give bananas and if I give apples, all the bananas will be put in one basket, all the apples will be put in one more basket. But the kid doesn't know apple is an apple or banana is a banana, because we never label if these features are there, it is a banana, or if these features are there, it is an apple. Like that we are not telling. Only we are asking him to put items of similar type into one bucket. That is called unsupervised learning. So in future, whenever somebody asks unsupervised learning, what should flash in your mind is clustering. Clustering of similar items is called unsupervised learning. Okay. We'll try to, I will just try to expose you some more technical terms in the supervised learning and unsupervised learning. And you should not forget these things in future. So as supervised learning means, you need to remember two terms. Supervised learning will have only two terms called regression and classification. These are the two terms you need. For every learning, you need to understand two terms. For supervised learning, you need to understand classification and regression. For unsupervised learning, you need to understand clustering and association. For reinforcement learning, you need to remember two words called rewards and penalty. This is a simple thing. So what I told you is supervised learning, you need to have, whenever somebody asks supervised learning, immediately what should flash in your mind is regression and classification. What is meant by regression? What is meant by regression means, see, for all these things, slowly we'll go into the algorithms later, but you need to have these basics very clear so that we can understand the algorithms very easily. Actually, machine learning is very, very simple. Okay, even in China, they are teaching machine learning and deep learning from the class 4. Okay, everybody is becoming expert on this machine learning, deep learning from the class 4 itself. They are trying to overtake even US as far as machine learning and deep learning is concerned. And whoever is extremely good in US, who are the Chinese guys, they are getting them back to China by giving them more salary, so that they wanted to build this expertise in the China itself going forward. So in the supervised learning, what I told you is there are two terms you need to understand. One is called regression and another one is called classification. What is meant by regression? Regression means continuous. Suppose one pen is 1 rupee, 2 pen is 2 rupees, 3 pen is 3 rupees, 4 pens 4 rupees. What is the cost of 10 pens? Immediately you will tell 10 rupees. That is what is called regression. Regression means continuous. One book 10 rupees, two book 20 rupees, three book 30 rupees. What is the cost of 9 books? Immediately you will tell 90 rupees. That is called regression. Regression will look like y is equal to mx plus c graph. It is a straight line graph. It can also be non-linear, but it is most like a straight line graph where on x-axis something will be there, y-axis something will be dependent and independent variables will be there. So from one variable you can basically predict the other one. That is called regression. So in future, regression means immediately what should come to your mind is it's a continuous, means 1 pen 1 rupee, 2 pen 2 rupees, 3 pen 3 rupees. What is the cost of 10 pens? 10 rupees. That is called regression. What is meant by classification? Classification means yes or no, black or white, tall or short, male or female. These are basically called classifications. Okay, so these are the two properties. Suppose if the student gets more than 40% pass, student gets less than 40% fail. That is called classification. Hope you understand what is meant by classification and what is meant by regression. Why I am using these terms is in supervised learning, there are some supervised machine learning algorithms. Those algorithms can be used either for classification or for the regression. That is the reason you need to understand these two terms, classification and regression. Hope it is clear. I just wanted to tell once again, please don't forget, because all these fundamentals we use in the deep learning very nicely. What is meant by supervised learning means somebody teaches you something, you learn. That is called supervised learning. In supervised learning, we have features, labels, and the model. Okay. And whenever somebody talks about supervised learning, what should flash in your mind is immediately the supervised learning algorithms will be used for either regression or classification. Regression means continuous, means 1 pen 1 rupee, 2 pen 2 rupees, 3 pen 3 rupees. What is the cost of 5 pens? Immediately you can draw the graph. 1 pen 1 rupee, 2 pen 2 rupees, 3 pen 3 rupees. You can take these 3 points, draw the graph, then you can predict any new value easily. That is called regression. Classification means yes or no, black or white, male or female. That is basically called classification. Okay. Hope you are very clear about what is meant by supervised learning, what is features, what is labels, what is model, what is meant by regression, what is meant by classification. Unsupervised learning. When it comes to unsupervised learning, what should come to your mind is unsupervised learning is nothing but clustering. Means if you give any items to some kid, items of similar type will be put it in one basket. Suppose you take our population. We wanted to apply unsupervised learning on population. 0 to 20 years, one set of people, 20 to 40, one set of people, 40 to 60, one set of people, 60 to 80, one set of people. Now, once I did the clustering, I just wanted to know, I wanted to sell a car. I wanted to do the marketing. So can I sell a car to 0 to 20 years of age of the people? No, their affordability is less. Usually you can sell either cycle or scooter to them. But 20 to 40, yes, definitely you can go and position your product into that segment. So it is basically used for market segmentation, this unsupervised learning. Okay. So I just wanted to tell you once again, unsupervised learning means you need to remember two words. One is called clustering and another one is called associativity. This is the second word you have to understand. Associativity is the another word that is used in the unsupervised learning. Suppose you go to some supermarket, you want to buy a bread. But the way they arrange the items is adjacent to the bread, they will put a butter. Adjacent to the butter, they will put a jam. Adjacent to the jam, they will put a eggs. Means if you buy one item, what is the probability that you buy the other items? That is called associativity. Like if you go and do some shopping in the Google, some shopping in the Amazon, if you buy some item, they will also show the people who have purchased this item, they have also purchased the following items. So though you will tend to buy the other items also. If you buy a mobile phone, you may buy the mobile phone cover also. That is called associativity. So when I tell any time about unsupervised learning, the two things should be there in your mind. One is called clustering. Clustering means items of similar type will be put into the one bucket. There is no labeling there. The second characteristic of the unsupervised learning is associativity. Means if you buy something, what are the other items you can buy? That is called associativity. These two terms should be there in your mind when we talk about unsupervised learning. We'll talk about the dimensionality reduction later. So hope you are able to understand what is machine learning, what is supervised learning, what is unsupervised learning. We'll talk about one more thing called reinforcement learning. So I already told you reinforcement learning means somebody will ask somebody to do something. If they do that work, they will get an awards. If they don't do that work, they will get penalties. Suppose the example is you take a dog, you ask the dog, go and get the ball. If the dog will go and get the ball, you give a biscuit. That is an award. If it doesn't get the ball, you will give a beating. That is called penalty. That is how the reinforcement learning will work. So these three terminologies with two examples should be very clear. Supervised learning means regression and classification. Unsupervised learning means clustering and associativity. Reinforcement learning means rewards and penalties. These terms should be there in your mind very, very clearly before going further. Okay, now we are going to really get into the machine learning. Once you have this basics clear, we will try to understand now what are the machine learning algorithms. So this slide should give you the crux of different machine learning algorithms. So what I basically told you is, as a part of machine learning, we have three varieties of learning: supervised learning, unsupervised learning, reinforcement learning. So corresponding to this each learning, we have also understood about supervised learning will have regression and classification, unsupervised learning means clustering, and reinforcement learning means rewards and penalties. So corresponding to these things, the Python guys have already developed these algorithms. These algorithms are named like this: linear regression, machine learning linear regression algorithm, logistic regression, support vector missions, K-means clustering, principal component analysis. Just for example, I have taken only 5 machine learning algorithms, but some more will be there. So I just wanted to now make you to understand small thing. What I'm basically telling is Python is a programming language which is very easy to program. It doesn't take much time as compared to C, C++ or Java. Inside the Python, they have developed a machine learning package that is called scikit-learn. Scikit-learn, S-C-I-K-I-T, scikit-learn. Scikit-learn is a machine learning package which is basically provided as a part of the Python for doing any machine learning programming. In the machine learning, you need not do any programming at all. You just give input and output to one of the algorithms. It will automatically create the model. If you give any input to the model, it can predict the output. So programming is very, very less in this aspect. Okay, what I basically told you is, in the supervised learning, if you take an example, we have regression and classification. In the regression, they provide an algorithm called linear regression. So what you have to do is, just you call that algorithm. For that algorithm, you give input and output. It will automatically build a model. For that model, you give any input, it will predict the output. That's all is the machine learning programming. Very simple. Okay. The same thing is true with any algorithms. We will try to see how it will be done in the Python. I will take one small, I just wanted to go to little hands-on experience before going further. So you must be seeing this slide. If you wanted to do any machine learning program, what I am basically talking about is either you can use MATLAB or you can use Python. Here we are going to talk about the Python. Python is widely used programming language. Inside the Python, scikit-learn, you must be seeing here, scikit-learn. Scikit-learn is a machine learning library which has implemented all the algorithms which we talked about in the earlier slide, like linear regression algorithm, logistic regression, support vector machine, decision tree. We'll talk about those things. But what I wanted to tell is this Python package has already implemented all these algorithms. We need not write any program for these algorithms at all. You call the algorithm, you give input output, it will build the model automatically. So that is scikit-learn. Inside the Python, there are some more packages in addition to scikit-learn. Scikit-learn will use some more packages called NumPy, SciPy, Matplotlib. NumPy, Pi means Python, Num means number. Means if you wanted to do any number addition, subtraction, anything, NumPy software will be used. I just wanted to tell you one more thing. If you wanted to become expert in machine learning and deep learning, you need to be very good in statistics and the linear algebra. Those are the two fields that will be used in machine learning and deep learning. Linear algebra, which is nothing but the matrices, and the statistics, which will basically contain arithmetic mean, mode, median, and probability stuff. Okay. So NumPy is the package which is used for number crunching. SciPy is a Python scientific library, which is based. It is like we used to have two varieties of calculators earlier: scientific calculator and ordinary calculator. Ordinary calculator will be used for adding regular numbers like 1 + 2, 3, or addition, subtraction, multiplication, all that. But whereas if you wanted to do any scientific calculations like sin x, e to the power of x, log x, we usually use it to use scientific calculators. Am I correct? So similar to that, NumPy and SciPy are the Python number and Python scientific library packages which are used in the machine learning. Matplotlib, PLOT, plot means for drawing the figures. Okay, if you wanted to draw any figures, you use Matplotlib, or if you wanted to draw any graph or anything. So when you basically wanted to work on the machine learning, you need to have the idea about these packages called NumPy. NumPy means Python numbering library. SciPy, that is Python scientific library, and Matplotlib, which is basically used for plotting the graphs. And scikit-learn is a library which has implemented all the machine learning algorithms. We need not implement any algorithm. Just you call the algorithm, give the data, input and output data, it will automatically build a model. The programming in machine learning is a 2 minutes job. Whereas the same thing if you have to do in computer, it will take many days. Okay. So the machine learning program you can learn in just 5 minutes. It doesn't take more than 5 minutes for you to become expert in the machine learning programmer. So I just wanted to recap once again. As a part of the Python, we have a library called scikit-learn, which is a machine learning library, which has implemented all the machine learning algorithms. Whichever the algorithm you wanted to use, you call that algorithm, you give input data and output data, it will build a model, and you give to the model any input, it can predict the output. That's all. It is any machine learning program is only 3 lines of code. That's all. Only 3 lines of code. If you want to write any code inside the machine learning, you have to write only 3 lines of code. That's all. Hope it is clear what is meant by machine learning, and as a part of machine learning, what is supervised learning, what is unsupervised learning, what is reinforcement learning. And we also talked about as a part of machine learning, what is the software. If you wanted to write any program in the machine learning, what is the software? So I basically talked about Python. Inside the Python, there is a machine learning package called scikit-learn, which implements all the machine learning algorithms. And it will also use some more packages called NumPy, Python number library, SciPy, that is Python scientific library, and Matplotlib, which is basically used for drawing any data. Okay. I will show you one small program to get the feel of how the machine learning program will be done. So that it is very easy, too easy actually. See, this is a small program. It is called linear regression. Very simple program. Yes.
Sir, can you put it in the slideshow mode, sir?
Slideshow.
Slideshow mode.
Is it better, sir?
Yes, sir.
Okay. So linear regression comes as a part of the supervised learning. Whenever I tell supervised learning, something should flash in your mind, regression and classification. And one more thing that comes to your mind is, in supervised learning, you give input and output, it will build a model. Using that model, if you give any input, it can predict the output. That's all I told you about the supervised learning. So I will try to explain to you how this Python scikit-learn library will be used. So what I told you is, if you wanted to write any program in machine learning, it is only 3 lines of code. That's all. We need not use our brain too much. It is only 3 lines of code. So what you have to do is import these libraries, import matplotlib, import numpy, import pandas, import scikit-learn. Pandas is another package which we did not talk about. Whatever data you give, it will try to represent in the matrix format. That is the main function of the pandas. So numpy is basically used for Python number manipulation. Yeah, SciPy is used for scientific data calculation. Matplotlib is used for drawing. And pandas is used for representing the data in matrix format. Why matrix format? Because overall machine learning is nothing but linear algebra, matrix manipulation only. And import sklearn. Sklearn is nothing but scikit-learn package. These are the libraries you need to import from sklearn. Okay. Now, the next line is from sklearn. What I told you is the scikit-learn will contain lot of machine learning algorithms. What are the different machine learning algorithms we talked about is linear regression, logistic regression, support vector machine, decision tree, random forest, lot of things we talked about. Here we are taking an example called linear model. From scikit-learn, import linear model. Okay. So what is the input data and output data I am giving is like this. Height, weight, height 4, weight 16, 5, 25, 6, 36, 7, 49, 8, 64, 9, 81, 100, 10, 100. So I have given input data and output data. Because in supervised learning, in linear regression, we need to give input and output to the algorithm. So what you have to do is, you give this input and output to this linear regression model dot linear regression. Means we are calling linear regression function. For this function, you use one method called fit. This is the important thing you need to understand. If you wanted to write any machine learning programming, first step is you need to collect the data. So here I collected the data, that is input data and output data I collected. That is the first step for machine learning. Data collection is an important. Input data, output data is nothing but height and weight. That is the first step. The second step is you need to decide, depending upon this data, what machine learning algorithm you want to use. So here I have expressed saying that I wanted to use a linear regression. If you don't want to use linear regression, you can replace with decision tree, random forest, support vector machine, whatever algorithm you want, you have to write that name here, model dot, instead of writing linear regression, you can write whatever the algorithm you want. That is the second step. First step is getting data. Second step is identifying the algorithm. Then what we'll do is, we'll basically take this data and give it to this linear regression algorithm. Then it will build a model. It will build a model. So the model will be built by using a function called fit method. So that is the third step. Fit method. So you basically call fit method by giving this input and output. It will build a model automatically. So the next step is prediction. Once the model is ready, you give some input as a height, it will automatically predict the weight. That's all is the machine learning programming. So I just wanted to repeat once again, if you wanted to write any machine learning programming, you need to take first data. Since it is a supervised learning, we are taking data as input and output. The first step is get data, which contains input and output. The second step is select the machine learning algorithm. I selected the algorithm as a linear regression. Okay. To this algorithm, you give this input and output data using the method called fit. Reg.fit, height and weight you give. Once you give input and output, it will build a model. To this model, you give any input, you can predict the output. So prediction will be done using the predict method. So those are the 4 steps in any machine learning algorithm: getting the data, identifying the algorithm, giving this data to the algorithm, so the model is built. Once the model is built, you give any input, the output. That's all. Very, very simple. Even the class 6, class 7, class 8, any guy can do this programming. I don't think we need to have really BTech or MTech degree for understanding this. That's why I'm telling you, in China, they are introducing this machine learning and deep learning from the class 4. They wanted to beat the US guys on machine learning in AI fully. Now China is going to be a export country as far as machine learning and deep learning is concerned. Any questions, please? So this is the crux of the any program in machine learning. You need to import the libraries, you need to get the data, you need to identify which algorithm you want to use. To algorithm, you give input and output data, the model is built. Model means function is built. To that function, you give input, you will get an output. That's all. Is it clear? Any questions, please? This is the crux of the machine learning. So in order to run these programs, you can use, this is called Anaconda. Anaconda is a software which you can download on your machine, whether it is a Linux machine or a Windows machine. And once you basically download this Anaconda, you can basically go to this Jupyter notebook. So using the Jupyter notebook, you can enter your program and execute the program. Okay. So, yeah. Okay. Just you have to go over here, Python 3.
Sir, we are not able to see the screen, sir.
This is basically a Anaconda screen. I think I need to share this screen. You are
Yes,
not
sir.
able to see the Anaconda screen, sir?
No, sir, no, sir.
Okay, now it will come. Just now you must be in a position to see.
Yes, sir, yes.
Is it clear, sir?
Yes, sir. We
Are
can
you able to see?
Yes, sir, yes.
Hello?
Yes. Sir, we can see, sir.
Yeah. So what I'm telling you is, if you wanted to do any programming in machine learning, there are different softwares available. One software I'm talking about, this is basically called Anaconda. Anaconda is called IDE. IDE stands for Integrated Development Environment, which is basically used for putting the program, compile the program, and test the program. So inside Anaconda, there is something called Jupyter Notebook. So I just invoked the Jupyter Notebook. You are getting this prompt. So you can enter your program here and execute the program. So I will just take one program and show it to you how to execute, so that you will get the feel of it, how to run the, unless you do hands-on, there is not much use of this course. Sir, you are able to see the screen now?
Yes, sir, yes.
I put the code. Is it clear? You are
Yes,
able
sir.
to see?
Yes, sir.
So I run the code. I am running the code. Whatever I explained, I entered that code into the Anaconda and I am executing the code. So it will take some time for executing the code, because you are giving input and output. It has to build a model. Model building, it will take time. Whereas if you give input, say you got the output 123, so it predicted 123. You got the feel of it now? So we basically gave input and output. We trained the system with the input and output data. Once the system is trained, the model is built. To that model, I gave an input height as 12. It predicted 123. what it's supposed to predict according to you? Actually, this equation now 416, 525, 636, 749. This equation is nothing but y is equal to x square. Am I correct? Y is equal to x square. Suppose if I give 12, it's supposed to predict 144, but whereas it predicted 123, because we have used linear regression. For non-linear data, you need to use a non-linear regression algorithm. That's all you have to decide. So we supposed to predict 144, whereas it predicted 123. So the 144 minus 123 is called error in prediction. If you want to remove this error, either you need to change this algorithm. Instead of linear regression, you go to non-linear regression, or you give more data. That's all. Did you get the feel of it? How the programs will run? See, this is the graph, how it will be drawn also. This graph will be drawn by matplotlib. Is it clear? Any questions? Okay. So, hope you got the feel of what is meant by Anaconda. Anaconda is a Python IDE. Inside Anaconda, there is a Jupyter notebook. Inside the Jupyter notebook, I entered the code, I executed the code, and I am able to basically predict value for 12 as 123. That's all is called linear regression. Any questions, please, before going forward? I think you need to have these basics very clear before going forward. Sir, can you please find out, sir? Are they clear about this programming? A very, very simple program. Python machine learning program is only 3 lines of code only. You need not write too many lines of code.
Sir, they are putting in the chat box that they have understood, sir.
Very good, sir. Thank you. Thank you very much.
Yes.
So I just wanted to spend another 10 minutes on machine learning, then we'll switch over to the deep learning very fast. Sir, what I wanted to tell you is, in machine learning, we have supervised, unsupervised, and reinforcement algorithms. Okay, these algorithms are called linear regression, logistic regression, decision tree, random forest, support vector machine, naive Bayes algorithm. There are different algorithms are there in the machine learning. I will try to spend 2 minutes to give you the feel of how to use these different machine learning algorithms. So whenever you basically get the data which is linear, like 1 square feet of land is 100 rupees, 2 square feet of land is 200 rupees, 3 square feet land is 300 rupees, 5 square feet is how much? Then you will tell immediately 500 rupees. This is called linear regression. For solving these kind of problems, you have to use linear regression. Means you need to go to scikit-learn and you need to basically call a linear regression machine learning algorithm. Suppose you are giving students data where we wanted to find out if the students' marks are more than 40, pass, less than 40, fail. For that, you have to use logistic regression algorithms. Okay, logistic means yes or no, pass or fail, male or female, black or white. For that kind of things, you have to use, for classification problems, you have to use logistic regression algorithms. Okay. Then there is one more thing called random forest. Random forest. Random forest means inside the forest we'll have the trees. Pick up some trees and do the decision making. Okay. Suppose I will give the example of random forest like this. Somebody came to Bangalore. Somebody basically came to Bangalore from Mysore. But because of the change of climate, that person has got a cold. Now he has to go to a doctor. He or she has to go to a doctor. So for going to doctor, what that person will do is, whichever the area that person is living, he will go and talk to 5 people. I have cold. I wanted to go to the ENT doctor. Can you tell me who is the best doctor? So each one will tell some doctor name. Out of 5 people, if 3 people will tell one doctor name, usually we will go to the doctor. Am I correct? That is called random forest algorithm. You wanted to go to a movie. You wanted to basically go to a movie. So before going to movie, you will basically talk to 10 people. Out of 10 people, if 6 people will tell the movie is good, you will go to movie. If they tell, if six people will tell movie is not good, you don't go to that movie. That is called random forest. So this is basically applied even on the Google also. Whenever you want to buy something, you will go and see the ratings. If more people will give 5-star rating, you think that product is good, you will go ahead and buy. That is called random forest. So in the random forest, what happens is forest will have a tree. The tree is nothing but a decision tree. For each decision tree, you give a problem. It will give an answer yes or no. If more, suppose random forest, we have taken 5 trees. For 5 trees, we will basically will give one movie name, whether this movie is good or not. So the tree one tell yes, yes, yes. 3 trees told yes, 2 trees answer came no. Then you basically go to that movie. That is called random forest. So the random forest algorithm you have to use whenever you have more data, divide the data, give it to each tree, and output of each tree you have to take. If more output comes, yes, you take the decision. Otherwise, don't take the decision. That is called random forest and decision tree. So we talked about linear regression. We talked about logistic regression. We talked about decision trees. We basically talked about the random forest. There is something called support vector machine and naive Bayes algorithm, 2 more. Support vector machines are basically used to distinguish the given data into 2 parts. Suppose to any kid, if you give an apple, if you give a pomegranate, both will look similar, red color. But depending upon the features, how do you separate these two is basically called support vector machine. Okay, support vector machine is basically used for classification problems where you have binary, means if you give any fruit, either the fruit may be apple or the fruit may be a pomegranate. That is basically called support vector machine. Naive Bayes algorithms are basically used for in the probability. Suppose you are getting mails in your Gmail. There are some mails which are good. There are some mails which are spam mails which you don't want to see. So depending upon the words, it will find out in the mail. It will try to basically predict whether the mail is a real mail or spam mail. If it is a spam, it will put into the spam mailbox. Otherwise, it will put into the regular mailbox. So the naive Bayes algorithm is used for finding out the mail is a spam or not. Okay, these are the 6 machine learning algorithms we discussed. Linear regression, which is basically used for continuous data. Logistic regression algorithm, which is used for classification. And we talked about decision trees and random forest for taking the decisions. And we also discussed about support vector machines, which is basically used for classifying the data into 2 parts. And we also talked about naive Bayes algorithm, which basically runs on the probability. If these words are there, what is the probability that the mail is a spam? For that, they will use something called naive Bayes algorithm. So these are the different algorithms. Depending upon the situation, you need to basically decide what kind of algorithm you need to use. Whether you need to use linear regression, logistic regression, decision tree, or support vector machine, or you have to use naive Bayes algorithm. So there are different algorithms. All these algorithms will come in the supervised learning, whatever I talked. And in the unsupervised learning, one more algorithm comes called K means clustering. K means clustering. Suppose we have the population of India. I wanted to divide this population into 5 clusters. I can use K means clustering, means 0 to 20 years, 1 cluster, 20 to 40 years, 1 cluster, 40 to 60, 1 cluster, 60 to 80, 1 cluster, 80 to 100, 1 cluster. So whenever you wanted to have clustering, you use an algorithm called K means clustering. And K means clustering algorithm will come in the unsupervised learning. Unsupervised learning. Any questions on these algorithms, please? You are able to get the feel of it, how to use which algorithm depending upon the context. Any questions, please? So that we can go to the next topic. Okay.
Sir, there is no question. We have understood at least.
Okay.
You can continue.
Okay. So what I basically told you so far is you understood what is meant by supervised learning, where somebody will teach, you learn. Unsupervised learning, you learn on your own. And we discussed about some of the features in the supervised learning called features and labels and the model. Features are nothing but input, labels are nothing but output, model is nothing but a function. That is what we discussed in the supervised learning. And we also discussed about what is meant by classification and regression in the supervised learning. And we also discussed some of the algorithms in the supervised learning, like linear regression, logistic regression, decision tree, random forest, support vector mission, and naive Bayes algorithm. And we also discussed about unsupervised learning. When I tell unsupervised learning, what should flash in your mind is unsupervised means no teacher. Learning something on your own is called unsupervised learning, where you give only features. There are no labels. So whatever input comes, you basically build a clusters or association. Inside the cluster, you can build an association. That is called unsupervised learning. Inside the unsupervised learning, there is one algorithm called K means clustering. Means depending upon the number of clusters you give, the given data will be divided into the clusters. That is what we talked about the unsupervised learning. Then the third one, which is very, very important, which is used more in the robotics kind of environment, is reinforcement learning. Reinforcement learning, when I tell reinforcement learning, what should flash in your mind is, if somebody tells something, if you do it, you will get an award. If you don't do it, you will get a penalty. So when I tell reinforcement learning, immediately what should come to your mind is rewards and penalties. Okay. So this is the example. So in the reinforcement learning, there is an agent, there is an environment. So suppose if there is a dog, this is the environment, there is a person, this person will tell dog, go and get that ball. This dog will go and get the ball, he will get a reward, that is a biscuit. If he doesn't get, he will get a beating. That is basically called penalty. That is how the reinforcement learning will work. So whenever I talk reinforcement learning, what should flash in your mind is rewards and penalties. Supervised learning means regression, classification. Unsupervised learning means clustering and association. So for every learning, you need to have these two terms registered in your mind. So there are different algorithms again in the reinforcement algorithms. They are called Q-learning, policy gradients, Bellman equations, Markovian decision process, and deep Q-learning. These are the different kinds of algorithms available in the reinforcement learning. I don't think we have enough time to go much more in depth on each of these things. But what I wanted to tell you is this reinforcement learning will work like this. You basically, suppose I am there at one place, somebody will tell from this place to this place, you go within half an hour. Then what I will do is, I will try to find out the different ways. From here, I will go to some distance by auto. From there, I will take a metro. Suppose I am there in Dayanand Sagar University, in Electronic City office, I have to go to Majestic. So somebody will come and tell me, from Electronic City office to Majestic, can you go in half an hour? Somebody may go on bus, they may take 1 hour. Somebody may go on auto, they may take 45 minutes. Somebody may go in Vola, they may take 30 minutes. But this person basically told, can you basically go in 25 minutes? Then what I will do is, I'll go up to certain distance by Vola to metro. From metro, I'll get into metro and go to Majestic in 25 minutes. So what I am telling is, from source to destination, you have different ways to take the decision. Which decision you can take so that your goal can be met. If the goal is met, means if you go from one place to another place in 25 minutes, you will get a award or reward, otherwise you will get a penalty. That is how all these reinforcement algorithms will work. Okay. One more example I can give. Suppose somebody told you saying that whenever train comes, you need to get into the train within 5 minutes, 5 seconds. So what happens whenever train comes on the platform, usually everybody will try to get into the train. They will push each other, they will fight each other, they will lose peace of mind. After 10 seconds, you will go and sit in your seat, and then you will keep thinking, why did I fight with this guy? Why did I push that guy? Why that guy has pushed me? All these thoughts will come into your mind. But seeing that environment, whenever train comes, immediately everybody is going. So seeing that environment, one more guy may think in different way. Okay, let all the people go inside. After everybody go inside, this guy will walk coolly in 1 second and he will go and sit in the seat. So by seeing the environment, you dynamically take the decisions in the reinforcement algorithms. Okay, is it clear? So that is how the reinforcement algorithms will come into the picture. Means from source to destination, you have different paths available. You take the best path, you will get an award. If you take the worst path, you will get a penalty. So your system has to be trained in such a way so that you always get more awards. But that will come through experience. So the reinforcement algorithms will work on the experience. Because even if you take the dog problem, the dog has got the experience saying that somebody is telling me to go and get the ball. If I get the ball, I'll get a biscuit. If I don't get the ball, I am getting a beating. So next time if somebody comes and tells you go and get that, it has got already the expertise. Okay, this person is asking me to go and get something. If I get it, I'll get an award. If I don't get, I'll get a beating. So that is how these reinforcement algorithms will work. So these are the different algorithms available for reinforcement. One of the very good areas for doing the research, actually, the reinforcement algorithms. Hope you got the feel of what is meant by machine learning, what is meant by supervised learning, what is meant by unsupervised learning, what is meant by reinforcement learning. So now I will straight away go to what is called deep learning. We don't have time to do experiments because this has to be conducted for 1 day. We are trying to finish in 2 hours. Okay, what is meant by deep learning? So the difference between the machine learning and deep learning is very, very simple. In the machine learning, you have a machine learning algorithms already given to you. You give your input data and output data. It will build a model. If you give any input, it can predict the output. That is what happens in the supervised learning. In the unsupervised learning, just you give input data to the machine learning algorithm, it will give you the clusters, means it will give you the clusters. So that is how the machine learning works. Whereas if you basically take the deep learning, the way the deep learning works is between the input and output, multiple levels of processing will be done. Okay, multiple levels of processing will be done. That is called deep learning. So when somebody tells deep learning means between the input, suppose if you basically take an equation y is equal to 2x, y is equal to 2x, if I put x is equal to 1, I'll get 2. If I put x is equal to 2, I'll get a 4. That is called machine learning. But in the deep learning, what happens is between the input and output, there will be a multiple layers. Maybe y is equal to 2x, the output of y is equal to 2x will go to y is equal to 3x, the output of that is go to y is equal to 4x, then the output will come. Means between input and output, there are 3 layers. One layer is y is equal to 2x, another layer is y is equal to 3x, another layer is y is equal to 4x. Or am I correct? Suppose if you put x is equal to 1, the first layer will give output 2, that will go to next layer, 2 3 is 6 will go to the third layer, 6 3 is 18. 18 will come as an output. That is called deep learning. Deep learning means between the input and output, there is a multiple layers of processing that will be done. That is the simple example for you to get the feel of what is meant by deep learning. Okay. The one more important thing is this deep learning is basically built using our brain. Inside our brain, there are what are called neurons. We have trillions of neurons inside our brain, which are connected, which are basically used for taking the decisions properly. As you know, your brain will basically contain the left brain and the right brain. The left brain is basically used for logic and the right brain is basically used for creativity. So our aim is always to make sure that our left brain and right brain is balanced. Otherwise, the people will become mad. If you use too much left brain, if you don't use right brain, there will be misbalance and people will get into the problems. So here we will basically talking about more on the left brain side, logic. Okay. So what I'm telling is, Inside our brain, there are what are called neurons. Trillions of neurons will be there. Each neuron will talk to another neuron using the electrical signals, okay, so that the overall decision making can be done. I just wanted to explain you one more thing. In machine learning, the Python has basically provided a machine learning toolkit that is called scikit-learn. Am I correct? That what we understood. Like that, inside the Python, there is a deep learning toolkit that is called, one toolkit we are going to talk about is called Keras. So when I talk about machine learning, what should flash in your mind is scikit-learn. Scikit-learn is a software library used in the machine learning in the Python. But if you wanted to do any practical examples in deep learning, you have to use one more software package in Python called Keras. Okay, Keras is built on top of either TensorFlow or Theano or Microsoft Toolkit. Okay, Microsoft Cognitive Toolkit. If you, can you please put it in the mute mode? So if you wanted to write any programs in machine learning, use scikit-learn. If you wanted to do any programs in deep learning, use Keras. Keras basically provides high-level APIs which are built on top of TensorFlow to do the programming very easy in the deep learning. Okay. So in the deep learning, we basically use the software called Keras. In machine learning, we use the software called scikit-learn. In deep learning, there are, what I told you is deep learning means between input and output, you have multiple layers of processing. That's called deep learning. So the deep learning is basically built on top of what is called neural networks. Okay. Neural networks are basically used for simulating the neurons inside your brain. See, overall our aim is to make the computer like a human being so that it can see, it can think, it can do all the actions like a human being. That's all is called artificial intelligence. It can do speech recognition, it can do pattern recognition, it can behave like a robot, it can do, it can identify the images using the computer vision. So basically making computer as a human being is nothing but the artificial intelligence. Providing whatever intelligence we have inside the computer is called artificial intelligence. Neural networks means our brain has got a lot of neurons. So if you wanted to basically simulate the neuron, you basically use what are called neural networks in the deep learning. So each neuron will look like this. This is called artificial neuron. Each neuron will look like this. The neuron will take an input called x1, x2, xn. Each input will have a weight, W1, W2, W3. The weight depends upon the importance of the input. If the input importance is more, the weight will be more. If the input importance is less, the weight will be less. So what this artificial neuron will do is, it will take an input x1, it will take a weight w1, it will multiply x1 w1, x2 w2, x3 w3, it will add all these things. This is basically what is called artificial neuron. So whatever the output you get after adding all these neurons, you give it to what is called transfer function. Here the transfer function this guy is using is called sigmoid. There are different types of transfer functions like tanh, sigmoid, relu. So here the function of this transfer function is whatever is input is given, the output will be either 0 or 1. The transfer function will give either output, either 0 or 1. That is how our neuron will work. Each neuron will do some work and it will basically create an electrical signal called either 1 or 0 inside our brain also. This is how the artificial neuron will look like. Artificial neuron will have an inputs. Artificial neurons will have the weights. The weight depends upon the importance of the input. Then the output of the neuron is nothing but x1 w1, x2 w2 or x3 w3 and sum all these and give it to a transfer function. The transfer function will basically give the output either 1 or 0. This is how the artificial neuron will work. Okay, if you basically integrate multiple neurons you basically create what are called deep neural networks. So overall, the deep neural networks are based on the fund of artificial neurons. So one more example, same thing. Suppose you wanted to implement the AND gate, this neuron. You wanted to implement an AND gate. AND gate will basically take two inputs, x1, x2, and it will give an output y. The output y, if 0, 0 means 0, 0, 1 means 0, 1, 0, 0, 1, 1 is 1. That is how the AND gate will work. Am I correct? It is a logic AND gate. So here we have basically taken two inputs. The input can be 0, 0, 0, 1, 1, 0 or 1, 1. And we have given weight as 0.7, for example. Okay. Then what it will do is, it will take input as 0, 0 means 0 into 0.7, 0 into 0.70. Like that 0, 1 also you can do one more. So like that, 0.7 into 0, 0.7 into 1, 0.7 into 1, 0.7 into 0, 0.7 into 1, 4 combinations of input, 0, 0, 0, 1, 1, 0, 1, 1. The output is coming as 0, 0.7, 0.7, 1.4. So the way we can write this transfer function is, if anything more than 0.7, the output value 1. If anything less than 0.7, it is a 0. So either you output 0 or 1. That is how we basically implemented this AND gate using the neural network. Hope it is clear. I wanted to tell you one more time. So this is the neuron. The neuron is implementing the AND gate. AND gate will have four inputs, 0, 0, 0, 1, 1, 0, 1, 1. 0, 0 means output 0, 0, 1 means output 0, 1, 0, output 0, 1, 1, output 1. That is how the AND gate works. Now we wanted to implement that AND gate using our neural networks. So you take input as A and B. We have put weight as equal weight, 0.7, 0.7. So what it will do is, if it is a 0, 0, 0 into 0.7, 0 into 0.7, 0. If it is a 0, 1 means 0 into 0.7, 1 into 0.7. If you add those two, you will get 0.7, 0.7, 1.4. So the transfer function we can write is, anything more than 0.7, the output is 1. Anything less than or equal to 0.7, it is 0. So the output can be either 0 or 1. Okay, that is how the AND gate implementation will work. We can do OR gate also. Yeah.
Sir, there is a question in the chat box. One from Megharani BM. She is asking
Sir, can I take the questions little at the end, because we don't have enough time. I have to get it.
This was related to AND gate, so I thought I'll ask you. No problem, sir. We can take it later.
Maybe at the end I can come back to the questions. I just wanted to go a little fast and finish the crux of the deep learning so that you will get the feel.
Okay, no problem, sir. No problem.
Okay, so what we basically discussed in the machine learning is, in the machine learning we basically talked about supervised, unsupervised and reinforcement algorithms. Am I correct? And corresponding to each learning, there are algorithms given. For supervised learning, they have linear regression algorithm, logistic regression algorithm, like that we talked about. When you basically come to deep learning, we have three kinds of deep learning networks. Three kinds of deep learning networks are there. So now we don't have enough time. We need to finish it. So we are going to talk about three networks. One is called convolution neural networks, recurrent neural networks, deep neural networks, and one more is there called GAN, generative adversary neural networks. We are going to discuss about four deep learning neural networks. One is called convolution neural networks. Another one is called recurrent neural networks. Third one is called deep neural networks. And fourth one is called GAN, generative adversary neural networks. There are a lot of things are there, but I just wanted to concentrate on these for this lecture. So first we'll basically talk about, we don't have time to go much in depth on all these things. So I'll basically talk about what is called convolution neural networks. What is meant by convolution neural networks? So convolution neural networks are basically used in the computer vision. This is basically used for image recognition. Image if you wanted to recognize the image, you basically use the convolution neural networks. So now onwards, if I ask you what is the use of convolution neural networks, what should flash in your mind is the convolution neural networks are basically used for image recognition or image classification. Okay, we'll see how it will be done. Then we talk about what is called recurrent neural networks. The recurrent neural, when I basically talk about recurrent neural networks, what should flash in your mind is astrologer. Okay? Astrologer. The recurrent neural network is more like an astrologer. What recurrent neural networks will do is, if you give present value, it can predict the future value or past value. It is more like it is basically used for predictions. The recurrent neural networks are basically used for predictions. So if you know the present value, you can find out the past value or you can use the future value. Suppose you know the value of the share. You wanted to predict the future value of the share. Suppose you take one company called Wipro or TCS or Infosys. I know the present value. So I can use the recurrent neural network for predicting the future value of the share. Okay, that is where the recurrent neural networks will come. So whenever I talk about recurrent neural networks, it is basically, that's why I used astrologer. It is basically used for prediction. It can either predict the future values or it can be used for predicting the past values. Whereas convolution neural networks will be used for image recognition and image classification. Okay. And there is one more neural network called GAN, that is Generative Adversary Neural Networks. GAN, G-A-N, Generative Adversary Neural Networks. These networks are basically used for discrimination. Discrimination means, I will give you one example. Suppose there is a police, there is a thief. The thief has basically printed 100 rupees note. Then he will take it to the police. The police will basically see the note and tell this 100 rupees note is a fake note because it doesn't have these features. Then the thief will go back, put all those features in the note. Again, he will go back to the police. Again, the police will see the note and tell these are the features missing from the real note. Again, the thief will come back and put those features and go to the police. Finally, police will tell, yes, this note is almost like a real note. So the GAN networks will be used for that kind of work. It is basically used for generating something and discriminating something with respect to the real one. Okay, you generate fake note, you try to compare with the real note, and the comparison will tell whether it is a real note or fake note. If it is a fake note, you come back, add more features so that it will exactly look like a real note. Those are the features of the generative adversary networks. So these are the three important things when I basically talk about deep learning neural networks, DNNs, what should come to your mind is convolution neural networks, recurrent neural networks, generative adversary neural networks. These are the three things should come. These deep neural networks will be used as a part of all the three. The deep neural networks will be used as a part of the convolution neural networks. That will be used as a part of the recurrent neural networks. It will be used as a part of the generative adversary networks. Understood? So, like in the machine learning, those algorithms should come to your brain. If I tell supervised learning, immediately what should come to your mind is logistic regression, linear regression, support vector machine, decision tree, random forest. So when I basically talk about deep learning, what should come to your mind is, first, deep learning is implemented by the neurons. The neuron structure should come to your mind. And the next thing, what are the different deep neural networks available are convolution neural networks, recurrent neural networks, and generative adversary neural networks. Convolution neural networks are basically used for image classification and image recognition. Recurrent neural networks will be used for prediction. You can predict anything. You can predict the shares or anything you can predict. And the GAN neural networks are basically used for generating some image to discriminate whether it is a real image or not. So these are the three important deep neural networks. So we'll take convolution neural networks. So the way the convolution neural networks will work is, these networks are basically used for convolution neural networks are basically used for image recognition or image classification. The way you have to do is, suppose you have three images: banana, apple, and orange. Banana, apple, and orange. You take the images of banana, apple, and orange, give it to convolution neural network. Then what it will do is, the convolution neural network will extract the features from the apple, banana, and orange, and it will label banana as a banana, orange as a orange, and apple as a apple with respect to the labels. Then when you give any new image, like if you show one more apple, seeing the features, it will predict it is an apple. Understood? Is it clear? So the way the convolution neural networks work is, you need to train the system with the images. So this is basically a supervised learning model where for each input you have a label. So you take three images, you basically take for each image features. If these features are there, you call this as an apple. If these features are there, you call this as a banana or orange. First, you need to train the system with that. Once you train the system, if you give any new image, it will try to basically get the features. Using that features, it will basically tell whether it is an apple, whether it is an orange, whether it is a banana. That is how the convolution neural network will work. Okay, it is basically used for image recognition or image classification. What is meant by classification? Classification means if you give cat and dog, it can tell whether it is a cat or a dog. That is called classification. This is one of the very important area for the electronics people to do a research. This is nothing but the signal processing only. Okay, so this is nothing but signal processing. Like if you have basically done a course on signals and systems, there is one chapter called convolution. So it will basically use convolution. Okay, let me explain how the convolution neural network will work. So the way the convolution neural network will work is, like when we are very young, we used to basically play a game called, the pieces will be given, we add all the pieces and try to basically get a shape like elephant, or what is that game called actually? All the pieces will be given to the kid. It's a building blocks actually, it's called building blocks. If you basically give all the building blocks to a small kid, they will basically attach all the building blocks in different permutations and combinations and finally derive some shape, maybe an elephant or whatever it is. It will work exactly like that. This convolution neural network will exactly work in that way. So the way convolution neural network work is like this. Suppose if you take an image, so we basically take a filters. These filters are nothing but the filters in the electronics only. Each filter is basically used for extracting some information from the image. So suppose if I basically take an image, if I basically use a filter, this filter can basically extract all the horizontal lines, all the vertical lines of the image. That is one filter. One more filter may extract intensity of the image. One more filter can extract the curved lines of the image. Like that, many filters will be used in the convolution neural network to extract the different features of the image. Once you extract all the features from the image, you basically give it to the deep neural network. That deep neural network, what it will do is, it will take all these features, and from all these features, it will build a middle level of features. Then it will build a upper level of features. What is meant by middle level of features? What is meant by upper level of features is like this. Suppose you extracted the lines, curves of the face. So if you give it to the deep neural network, it will take this lines and curves, it will come out with the eyes, it will come out with the nose, it will come out with the mouth, it will come out with the ears. That is called middle layer features. Then you give these middle layer features to one more deep neural network layer, it will add all these things and it will show you the face. Like that, it can be done for hands, it can be done for the middle part of the body, it can be done from the legs. These are called high end of the features, like legs, hands, head, like that. Once you give these high level features to one more network, it will build you the image and it will tell what is this image. That is how the convolution neural network will work. So convolution means extract. Convolution means extract the features. How do you extract the features? You use the filters, you keep on using those filters, you extract the features, you extract the low level features, again you take the low level features and give it to the deep neural network convolution layer, it will build the middle level of features, again give middle level of features to the one more deep neural network layer, it will come out with the high level features, then all these high level features will be given to the final classification network, it will basically tell whether it's a cat or a dog. That is how the convolution neural network will work. Any questions? This is one of the very, very important area. If somebody wants to do research in the computer vision, and if you have the electronics background, for the computer science people, it is very difficult to understand all these concepts. They don't have the understanding of filters and all that. But people with electronics background can understand deep learning much better as compared to the computer science people. So that is meant by convolution neural networks. Convolution means extracting the features of the image. You extract only the high level features, give it to one more network, middle level features will come, give it to one more network, you will get the high level features. All these high level features, you give it to the network, it will build the image. That is the function of the convolution neural network. Is it clear what is meant by convolution neural network, how it is used? So you can basically use Keras for basically doing any experiment using this convolution neural networks. So whenever you want to do any work with respect to image classification and image recognition, you will use convolution neural networks. So inside the Python, there is a package called Keras. The Keras can be used for doing the work on the convolution neural network. Here we are trying to do image classification and image recognition. We are not doing image processing. If you wanted to do image processing, which is a simple concept, you can use one more package in Python called SciImage. SciImage is a package which is basically used for image processing. Means you can reduce the image, you can make the image big, or you can cut some image, some corners of the image. That is all called image processing. But convolution neural network is not for image processing. It is for image recognition, image classification. Okay. So inside the convolution layers, I don't know how much in depth I should go because the time is ticking. I wanted to cover in 2 minutes what will be there inside the convolution neural networks. Inside the convolution neural networks, there are 4 layers will be there. You need to understand these layers. You need to remember CRPF. Like you have CRPF force, Central Reserve Police Force, no, CRPF, Central Reserve Police Force. You remember that CRPF. If you wanted to understand CNN, you need to understand CRPF. CRPF means C means convolution layer, R means ReLU layer, P means pooling layer, F means fully connected layer. These are the 4 layers will be there in the convolution layer. Convolution layer in the CNN network, convolution layer, R means ReLU. ReLU is nothing but a transfer function. Like in the neural networks, I explained you something called a transfer function, which will give you the output either 1 or 0. Like that, ReLU will basically give you any negative number, it will make it as a positive number. That is called transfer function. ReLU will do converting any number into the positive number. CRP means pooling layer. Pooling layer, what it will do is, if you take one matrix, 4 by 4 matrix, if you multiply with the filter, which is also 4 by 4 matrix, if you multiply 4 by 4 matrix with 4 by 4 matrix, you will get 4 by 4 matrix. Am I correct? Inside that 4 by 4 matrix, you take one maximum element, not all the elements, which are important element. That is called maximum pooling. It's called max pooling. It's called pooling. CRP. C means convolution. Convolution means take the filter. Filter is nothing but a matrix. Your image is also nothing but a matrix. It is n by n matrix. Take the filter, multiply with the image matrix, you will get one matrix. In each of the matrix, you have to take the maximum element, that's called max pooling. F means fully connected layer. This fully connected layer will come into the picture when you have multiple features are already extracted at the lower level, middle level or higher level functionality. Once you got all the higher level functionality features of this input, you give it to fully connected layer, it will tell whether it's a cat or dog. That's all. So you need to understand the mathematics very well. See one small example I am giving in the convolution. This is an image. Image is a 3 by 3 matrix. This is a filter, 2 by 2 matrix. What convolution layer will do is it will take this filter and it will multiply with the image. Like 1100 will be multiplied with 0.50. You will get one value. Like that, then you move this by one window. Means don't take 0, 0. That is called striding. You take again this 2 by 2 matrix, multiply by 2 by 2. Again you come down. If you keep multiplying like that, you will get one matrix. Oh boy, I don't know where. If you multiply like that, you will get one matrix. In that matrix, pulling the maximum element is called max pooling. Okay. So if you really ask me what we are doing all these things is nothing but if you have basically understood inside the electronics what is called image compression. What we are doing here in the max pooling is called image compression. Okay, image compression. Whatever big image is there, you try to extract the important features from that image and give it to the neural network for recognition. So this convolution, ReLU and pooling will be done to reduce the image size. And once the image size is reduced, you have limited number of features. You give those limited number of features to the neural network, then it will basically do the classification. That's all. So in CRP is basically used for reducing the image size to the small size. It's also called dimensionality reduction. Okay. I don't think we have much time. I think people who are interested, very, very good area to do the work on this. And you can contact me offline. I can provide you the programs. I can provide you the URL links where you can learn this convolution neural networks in 1 hour. Okay, it should not take more than 1 hour for you to learn about this convolution neural networks. There are very good examples are given. I have done the practice. I can share it with you. So I already talked about the neural networks. In the neural network, in the recurrent neural networks, what happens is you have the neurons. Each neuron will take an input, it will give an output. Whereas in the recurrent neural network, it will not only take the input and give an output, it will also take the output from the other neuron also. So there will be 3 neurons because by seeing the past, you can do the future prediction. That is the use of the recurrent neural networks. So the recurrent neural networks are nothing but matrix multiplication. If you do general matrix multiplication, you will get a future. If you want past, you do the transpose of the matrix, then you can go back. So either you can go back or you can go forward using these recurrent neural networks. So the recurrent neural networks are basically used for shape prediction, or you can do any prediction. And convolution neural networks will be used for the image classification, image recognition, or inside the image, if something is bad, you can also do it in the medical field. And inside the recurrent neural network, there is one more thing called LTSM. This is one version of the recurrent neural networks, long-term, short-term memory. In the recurrent neural networks, what happens is you can have only the short-term memory. If there is a cell, the cell can get only the input from the adjacent cell only. But if the cell wants to get input from earlier cells, LTSM will be used. Okay, so the LTSM networks are basically used for remembering not only the immediate input and also the old input also can be used. For that, it will use something called forget gate, but we need a lot of time to go in depth into LTSM. But what I wanted to tell at this point of time is recurrent neural networks are basically used for prediction. If you know the past, you can predict the future. If you know the present, you can predict the future or past. Like that, if you wanted to do that kind of work, you need to use recurrent neural network. And for this also, you can use Keras package. And code also I have given. So if you wanted to really learn this convolution neural network, there is one guy called Victor Zhao. He has done his MS from Princeton University. He is working in Google with 2-3 years of experience. He has given a lot of good examples on how to implement this convolution neural networks using Keras. And this code is also explained very well. So you have to take his code, put into Keras and put into Python Keras and execute it. You will get the feel of how this convolution neural network will work. Unless you do hands-on, there is no use of learning this machine learning or deep learning at all. So the last topic, we are left with only 5 minutes time. So the GAN, that is Generative Adversary Neural Network. This is the third type of neural network. Here what happens is, you take some noise vector and you basically create an image. You basically create a fake image. And you will have a real image. You compare the fake image with the real image using the discriminating network, and you predict whether this fake image is real or not. If it is not real, you come back, you keep on changing the parameters in the fake image till it becomes the real image. That for that kind of purpose, we basically use generative adversary neural networks. So when I basically talk about deep learning, you need to have these three things registered in your mind. Convolution neural networks, which are basically used for computer vision or image classification or image recognition. Recurrent neural networks, which are basically used for prediction. And generative adversary neural networks, which is used for discriminating the fake images versus the real image. Because nowadays, even in the internet, you will see a lot of fake news, fake images. We can really find out whether the image is real or fake using this generative adversary neural network. And I also basically gave some references. I don't think we have much time to understand much in depth of all these things, but I think in 2 hours, this is what we basically can cover. Okay. I hope you got some feel of what is machine learning, what is deep learning, what are the algorithms in the machine learning, what are the algorithms in the deep learning. So I request you to go and do practical experiments, then only you will get the feel of it. Otherwise, it is only a theory. Okay, so I just want to stop at this moment, and if somebody has got questions, they can basically call me offline. We can discuss about any more topic. I will share my mobile number with Prashant sir, and I wanted to thank all the people for attending the session patiently. I don't know how much you understood, and I just wanted to thank you all. Okay, thank you very much for your time. Bye.
Sir, can you answer a few questions which is there in the chat box?
Not now, sir. Maybe can they contact me over the mail or phone?
I have shared your email ID with them.
Yeah, I will share my email ID to you and my mobile number and WhatsApp number. And if they wanted to do any practical experiments, I will guide them. But I request all the people to execute all the programs given. Unless you execute these programs, you don't get the feel of this machine learning and deep learning. Okay. I request you to put hands-on, hands-on, hands-on. Theory, no use. And particularly people with electronics background, they can understand much better as compared to computer science guys. So it is your area actually. Okay.
Yes.
So I will share my email ID and my WhatsApp and mobile number. I request, and whatever questions, I will also share this presentation. Whatever questions you have, please send it. I can have one-on-one meeting with you and clarify doubts if I know. If I don't know, I will tell I don't know. Okay.
Yes.
Thank you very much. Yeah.
Sir, I would like to thank you for the wonderful session, and this was a little different, giving the touch to the real-time applications also. And I also, being in the neural network field, but
Yes, sir.
I was never used such type of applications to explain to the students. It was more of book-related concepts. We explain it to them. But I found this is very informative and interesting. So hope all the participants have ignited with such type of applications when they explain it to the students. So thank you very much, sir, for your time and effort. Hope we
Thank
will, the participants will be in touch with you for their
you.
research and
Definitely.
other course
Yeah.
deliveries also.
Thank you.
Thank,
Thank you very much, sir, for giving this opportunity. Thank you very much.
thank you very
Yeah.
much, sir.
Thank you.
Yeah, sir, you can sign off.
Okay, sir. Yeah.
Yeah. The participants, we will start our next session at 2:30, and I'll be sharing the feedback link for the session 1 as well as session 2 now. And please fill the feedback form.
Best of the thinkers, creators, innovators, and inventors. In fact, we believe in achieving more than ever before, instilling the commitment to strive continuously to serve the national and global needs. There are challenges we can't ignore, but remember, we are of humankind, and every objective is achievable by setting our minds, and Dayanand Sagar molds you to achieve the objectives in an environment that enhances creativity and innovation. If we all embrace the spirit that there really is no limit, if we rise to this occasion and come together across nations, if we integrate and ideate, we can make the future great and live the dream. Our legacy of education takes its root from our founding father, late Sri Dayanand Sagar, a visionary, an educationist, a powerhouse of knowledge and a believer in transforming the world, besides a leader par excellence. The institution has contributed to educating the world for over 60 years, carefully building alumni of over 100,000, including accomplished professionals, sports personalities, celebrities spread across the globe. We stand strong as a top-rated university having 4 campuses with 350 teaching staff, educating 4,400 students with pride-filled and powerful alumni network across the globe. Dedicated faculty members who work across disciplines, collaborating and lifting us as the top university in the world, empowering the rising generation and nurturing entrepreneurs. Dayanand Sagar University. Live the dream.
It's already late. Where's Arjun?
He's looking for universities, right? Maybe he's held up there.
You look so tense. By the way, did you get to choose the university?
No, I'm unable to find a university that meets my requirements.
Whoa. Meet your requirements? What exactly are you looking for?
I'm looking for a place that gives me an opportunity to grow, to excel, to invent, and to innovate. I want to be a part of an institution that paves my way to discover myself and to witness the world moving forward in technology. I want to go to a place that sets a futuristic pattern of education filled with ideas and radical performances. Basically, I want to live my dream.
Dayanand Sagar University. Live the dream. Time. The time proves that we have come a long way to get where we are today. Dayanand Sagar University, with the legacy of 6 decades, had contrived to the achievements today and is throwing light on the way forward. Our visionaries understood the need to learn and know, to do and grow, to twiddle and tweak, creating the best of the thinkers, creators, innovators, and inventors. In fact, we believe in achieving more than ever before, instilling the commitment to strive continuously to serve the national and global needs. There are challenges we can't ignore, but remember, we are of humankind, and every objective is achievable by setting our minds, and Dayanand Sagar molds you to achieve the objectives in an environment that enhances creativity and innovation. If we all embrace the spirit that there really is no limit, if we rise to this occasion and come together across nations, if we integrate and ideate, we can make the future great and live the dream. Our legacy of education takes its root from our founding father, late Sri Dayanand Sagar, a visionary, an educationist, a powerhouse of knowledge and a believer in transforming the world, besides a leader par excellence. The institution has contributed to educating the world for over 60 years, carefully building alumni of over 100,000, including accomplished professionals, sports personalities, celebrities spread across the globe. We stand strong as a top-rated university having 4 campuses with 350 teaching staff, educating 4,400 students with pride-filled and powerful alumni network across the globe. Dedicated faculty members who work across disciplines, collaborating and lifting us as the top university in the world, empowering the rising generation and nurturing entrepreneurs. Dayanand Sagar University. Live the dream.
It's already late. Where's Arjun?
He's looking for universities, right? Maybe he's held up there.
You look so tense. By the way, did you get to choose the university?
No, I'm unable to find a university that meets my requirements.
Whoa. Meet your requirements? What exactly are you looking for?
I'm looking for a place that gives me an opportunity to grow, to excel, to invent, and to innovate. I want to be a part of an institution that paves my way to discover myself and to witness the world moving forward in technology. I want to go to a place that sets a futuristic pattern of education filled with ideas and radical performances. Basically, I want to live my dream.
Dayanand Sagar University. Live the dream. Time. The time proves that we have come a long way to get where we are today. Dayanand Sagar University, with the legacy of 6 decades, had contrived to the achievements today and is throwing light on the way forward. Our visionaries understood the need to learn and know, to do and grow, to twiddle and tweak, creating the best of the thinkers, creators, innovators, and inventors. In fact, we believe in achieving more than ever before, instilling the commitment to strive continuously to serve the national and global needs. There are challenges we can't ignore, but remember, we are of humankind, and every objective is achievable by setting our minds, and Dayanand Sagar molds you to achieve the objectives in an environment that enhances creativity and innovation. If we all embrace the spirit that there really is no limit, if we rise to this occasion and come together across nations, if we integrate and ideate, we can make the future great and live the dream. Our legacy of education takes its root from our founding father, late Sri Dayanand Sagar, a visionary, an educationist, a powerhouse of knowledge and a believer in transforming the world, besides a leader par excellence. The institution has contributed to educating the world for over 60 years, carefully building alumni of over 100,000, including accomplished professionals, sports personalities, celebrities spread across the globe. We stand strong as a top-rated university, having 4 campuses
Hello, sir.
with 350 teaching staff, educating
Hello.
4,400 students with pride-filled and powerful alumni network across the globe. Dedicated faculty members who work across disciplines, collaborating and lifting us as the top university in the world, empowering the rising generation and nurturing entrepreneurs. Dayanand Sagar University. Live the dream.
It's already late. Where's Arjun?
He's looking for universities, right? Maybe he's held up there.
You look so tense. By the way, did you get to choose the university?
No, I'm unable to find a university that meets my requirements.
Whoa. Meet your requirements? What exactly are you looking for?
I'm looking for a place that gives me an opportunity to grow, to excel, to invent, and to innovate. I want to be a part of an institution that paves my way to discover myself and to witness the world moving forward in technology. I want to go to a place that sets a futuristic pattern of education filled with ideas and radical performances. Basically, I want to live my dream.
Dayanand Sagar University. Live the dream. Time. The time proves that we have come a long way to get where we are today. Dayanand Sagar University, with the legacy of 6 decades, had contrived to the achievements today and is throwing light on the way forward. Our visionaries understood the need to learn and know, to do and grow, to twiddle and tweak, creating the best of the thinkers, creators, innovators, and inventors. In fact, we believe in achieving more than ever before, instilling the commitment to strive continuously to serve the national and global needs. There are challenges we can't ignore, but remember, we are of humankind, and every objective is achievable. By setting our minds, and Dayanand Sagar molds you to achieve the objectives in an environment that enhances creativity and innovation. If we all embrace the spirit that there really is no limit, if we rise to this occasion and come together across nations, if we integrate and ideate, we can make the future great and live the dream. Our legacy of education takes its root from our founding father, late Sri Dayanand Sagar, a visionary, an educationist, a powerhouse of knowledge and a believer in transforming the world, besides a leader par excellence. The institution has contributed to educating the world for over 60 years, carefully building alumni of over 100,000, including accomplished professionals, sports personalities, celebrities spread across the globe. We stand strong as a top-rated university, having 4 campuses with 350 teaching staff, educating 4,400 students with pride-filled and powerful alumni network across the globe. Dedicated faculty members who work across disciplines, collaborating and lifting us as the top university in the world, empowering the rising generation and nurturing entrepreneurs. Dayanand Sagar University. Live the dream.
It's already late. Where's Arjun?
He's looking for universities, right? Maybe he's held up there.
You look so tense. By the way, did you get to choose the university?
No, I'm unable to find a university that meets my requirements.
Whoa. Meet your requirements? What exactly are you looking for?
I'm looking for a place that gives me an opportunity to grow, to excel, to invent, and to innovate. I want to be a part of an institution that paves my way to discover myself and to witness the world moving forward in technology. I want to go to a place that sets a futuristic pattern of education filled with ideas and radical performances. Basically, I want to live my dream.
Dayanand Sagar University. Live the dream. Time. The time proves that we have come a long way to get where we are.
Prasad sir, good afternoon.
Good afternoon, sir. Good afternoon, sir. ಕೇಳಿಸ್ತಿಗತ್ತ ಸರ್?
ಹಾ ಸರ್.
ಎಸ್.
ನೀವೇನು ಶೇರ್ ಮಾಡೋರು ಇದ್ದೀರಿ? ಒಂದ್ಸಲ ಟ್ರಯಲ್ ನೋಡ್ಬೇಕಾ?
ಪ್ರೆಸೆಂಟೇಷನ್ ಮಾಡೋದು ಮತ್ತೆ ಆರ್ ಸ್ಟುಡಿಯೋದು ಇದನ್ನ ಹಂಗ ನಾ ಡೆಮಾನ್ಸ್ಟ್ರೇಷನ್ ತೋರಿಸೋದು ಸರ್.
ಓಕೆ. Sir, 2 minutes start ಮಾಡೋಣ sir.
Okay sir. Okay.
Sir, how is the weather in Belgaum?
Sir, cool.
Cool, huh? Okay.
ಮತ್ತೆ ಸರ್ ಅಲ್ಲಿ ಕೋವಿಡ್ ಜೋರಾಗಿ ಬಿಟ್ಟದ್ಲ ಅಲ್ಲೇ.
ಹಾ ಸರ್.
ಇಲ್ಲಿ ಆಲ್ಮೋಸ್ಟ್ 30 ಏನೋ ಕೇಸಸ್ ಅವರು ಸರ್ ಬರೀ ಜಸ್ಟ್.
ಹಾ, ಬಟ್ ಇಲ್ಲೇನ್ ಬಿಂದಾಸ್ ಆಡಾಡ್ತಾ ಇದಾರೆ ಸರ್, ಏನ್ ನೋ ಇಶ್ಯೂಸ್.
ಮತ್ತೆ ಇನ್ನೂ ಮತ್ತೆ ಬೆಂಗಳೂರು ಲಾಕ್ಡೌನ್ ಮಾಡೋ ವಿಚಾರದಾಗ ಇದ್ದಾರಂತ SSLC ಪರೀಕ್ಷೆ ಮುಗಿದ್ಮೇಲೆ ಸರ್ ಎಕ್ಸಾಮಿನೇಷನ್.
ಇಲ್ಲ ಸರ್, ಮಾಡಲ್ಲ
ಮಾಡಲ್ರಿ.
ಇಲ್ಲ, ಮಳೆ ಶುರು ಆಯ್ತಲ್ಲ ಸರ್, ಇನ್ನೇನ್ ಮಾಡ್ತಾರೆ.
ಅಲ್ಲ ಏನೋ ಹಿಂಗ ನ್ಯೂಸ್ ನಲ್ಲಿ ಬರ್ತಾ ಇದೆ,
No,
SSLC ಎಕ್ಸಾಮ್ ಮುಗಿದ ತಕ್ಷಣ
I don't think sir
they
they
are
will
going
do
to.
it because many people they are actually not for that.
ಓಕೆ ಇಲ್ಲ ಸರ್, ಬಟ್ ಕಮ್ಯುನಿಟಿ ಸ್ಪ್ರೆಡ್ ಆಗೋ ಚಾನ್ಸಸ್ ಬಹಳ ಇದೆ ಅಂತ.
No, that is there, but all these small vendors ಎಲ್ಲ they are opposing. ಆಟೋ ರಿಕ್ಷಾದವರು, ಆಮೇಲೆ ಸ್ಮಾಲ್ ಹೋಟೆಲ್ ಇದ್ರವರೆಲ್ಲ ಅಪೋಸ್ ಮಾಡ್ತಿದ್ದಾರೆ. ಈ ವೆಜಿಟೇಬಲ್ ವೆಂಡರ್ಸು, ಫ್ಲವರ್ ವೆಂಡರ್ಸ್.
ಓಕೆ ಸರ್, ನಾ ಈಗ ನಂದು ಇದನ್ನಾಗ ಪ್ರೆಸೆಂಟೇಷನ್ಯಾಗ ಫಸ್ಟ್ ಸ್ವಲ್ಪ ಬೇಸಿಕ್ ಹೇಳ್ತೀನಿ ರೀ.
ಎಸ್ ಸರ್, ಎಸ್.
ಹಾ, ಬೇಸಿಕ್ ಅದ್ ಹೇಳಿದ ಮೇಲೆ ಒಂದು ಕೇಸ್ ಸ್ಟಡಿ ತಗೊಂಡು ಅದನ್ನ ಹೆಂಗ ಇದನ್ನ ರಿಸರ್ಚ್ ಯೂಸ್ ಮಾಡ್ಬೋದು ಅಂತ ಹೇಳ್ತೀನಿ.
ಎಸ್ ಸರ್, ಎಸ್. So you are the better judge than me.
ಇಲ್ಲ ಸರ್, ಹೇಳ್ತೀನಿ, ಹೇಳಿಕತ್ತೀನಿ.
I have told you my objective of the program. So
okay,
you are
sir.
the better judge.
ಅಲ್ಲ, ಅದಕ್ಕೆ ಹೇಳಿದೆ ಮೊದಲು ಸ್ಟಾರ್ಟಿಂಗ್ ಇಟ್ ವಿಲ್ ಬಿ ಅ ಬೇಸಿಕ್. Means I will give the introduction to R.
Okay sir.
Some commands over R. How can we use it?
Yes sir, yes.
Then I'll shift to the research work.
Okay sir, no problem.
Okay.
ಸರ್, ಸ್ಲೈಡ್ ಶೋ ಮೋಡ್ ಒಳಗೆ ಹೋಗ್ತೀರಿ?
ಸ್ಲೈಡ್, ಹಾ, ಓಕೆ ಸರ್, ಬಂತ?
ಹಾ ಸರ್. ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ?
ಹಾ, ನಡೀತದೆ, ನಂಗೆ ಏನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ ಸರ್.
ಓಕೆ ಸರ್. Good afternoon, sir. Sorry. Good afternoon, participants. Welcome to the day 5 of ISEP-2020 PAS session 3, which will be on R programming in research. I'll just introduce Professor Prasad Pujar to the participants. Professor Prasad Pujar is currently working as an assistant professor in the Computer Science and Engineering Department of KLS Gupta Institute of Technology, Belagavi. He did his bachelor's in engineering in Information Science and Engineering in 2005 from KLS Gupta Institute of Technology under Vishweshwaraya Technology, Belagavi. He completed his Master of Technology in Computer Science and Engineering in 2009, again from KLS Gupta Institute of Technology under VTU Belagavi. He is currently pursuing a PhD under the supervision of Dr. Harish Kenchannavar, who is heading the Department of ISC at GIT Belagavi. He is a life member of Indian Society for Technical Education, and he has a research publication of books, book chapters, and papers in reputed international journals and under international publishers, around 5 numbers. And he is actually interested in the wireless communication, and he's currently pursuing research under that wireless for IoT. Uh, Sir, with this brief introduction, I request Prasad sir to continue with the session. Thank you, sir.
Yeah, thank you, sir. Thank you, Patwardhan sir, for this introduction.
Welcome, sir.
Good afternoon, everybody. I am Professor Prasad Puja from KLS Jogokte Institute of Technology. I am, as sir has mentioned, I am pursuing my research in WSN IoT networks. So here I am going to present you the presentation on R programming. How can we use R programming in research? Because right now in my research, I am using R programming for my IoT networks. So uh, before 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 going to the research avenue, I shall just brief about what is R programming, how it all started. So, R programming. Uh, so R programming was basically started by two gentlemen called as Robert Gentleman and Ross Ihaka in the Department of Statistics of University of Auckland. So they started R programming in 1992. They were inspired by S programming, previously used as statistical purpose only. So R programming is basically named after the two authors, that is the Robert and Ross. That is the first alphabet of their name, R. So it is named as R programming. So initially it was released in 1995, but the stable version was released on 29th Feb 2000. So only after 2000 we are using R programming, or previously it was just used in the University of Auckland. Why R programming again? So basically R programming language and environment is used for statistical computing, as the R programming is basically was developed for statistical analysis. Now we can also use for data analytics and scientific research. Then why R programming? So basically it is used to it is basically used to retrieve the data, clean the data, analyze the data, visualize the data, and present the data. So the strong point of R programming is it can highlight the results in the form of graphical, you can say graphical output, in the form of graphs. So is R programming difficult? Some can ask, is R programming difficult? So as I've told you, it was basically designed for statistical and graphical analysis, but it can also be used for more stronger techniques or formulations or anything you can say, like linear and non-linear modeling, classical statistical analysis tests, time series analysis, classification, clustering. So classification and clustering are the parts of, you can say, machine learning concept, where we need to classify and cluster the data depending on the results. Then R has its own standard functions, which are basically written in R. So in my view, it is not at all difficult to learn. It is not at all difficult to learn. Then what are the benefits of the programming, R programming? So when we say benefits, I have highlighted some important benefits. Here, open source. As we know, nowadays everybody is trying or making use of open source softwares. Why open source? Because it is freely available. Then it is exemplary support for data wrangling. So when I say data wrangling is nothing but whatever the data, raw data that we get, it is clean, it is unified, and then presented into the system. So that we call it as data wrangling. Then wide array of packages. Yes, it makes use of wide arrays of packages. It has a wide array of packages, starting from, you can say, simple packages, which are used for, you can say, statistical analysis, to the neural networks nowadays that we are making use of. Deep neural network, artificial neural network, etc. All the packages are readily available in the R programming. Then, as I've told you, it is a good presenter. When I say good presenter, it provides quality plotting and graphical supports. So it has different types of charts that you can present in front of the people or the customers. Using those charts, you can easily tell what exactly the results that you have obtained. Then highly compatible. So when I say highly compatible, so it can range. That is, when I say highly compatible here, you can run any other codes like C, C++, even Python code in R. Even Python code in R. So because of that, I mean highly compatible. Platform independent, yes, you can run in any of the platforms. It may be the Windows, it may be the Mac, or it may be the Linux. Any platform, yes, you can run R programming. One more important feature or benefits of R programming is that, as I've told you, it supports machine learning. Machine learning is one of the upcoming, or you can say, hot topics, usually in the research avenues. So when we say machine learning, there are different algorithms of machine learning, starting from naive Bayes to deep learning and so on. So it supports each and every algorithm of machine learning. So these are some of the benefits of R programming. Then who are all using R programming? So you will be amazed to see that many top companies like Google, Amazon, Firefox, LinkedIn, ANZ, Flipkart. These are some of the companies I have mentioned. Well-known companies I have mentioned here, who are making use of R programming for their research and development, as well as data analysis. So before going to the research part, I'll just introduce you about some of the programming objects of R. So these are some of the basic, you can say these are the basic building blocks of R. There are 6 objects mainly, starting from vector to this frames. Starting from vectors, list, matrix, array, factors, and data frames. So these are the 6 objects that are basically used for the data retrieval and presentation. So what do we mean by vector? So basically a vector is the simplest type of data structure in R. A vector is a sequence of data elements of same basic type. So when I say vector, you can imagine of any data types in any of other languages like C, C++. When I say integer data type has the same set of elements. Similarly, vector also has the same set of same types of elements in the vector. So for example, here I have given you the example of apple. Apple is a vector. It is the name, vector name. Then what are the elements of the vector? So it makes use of the function called as C, which is adding the components. Using C, we can add the components in the vector. So apple is the vector. So using the C, that is the component addition, we are adding the colors of the apple here: red, green, and yellow. So here the next one is list. So are objects which contain elements of different types, like numbers, strings, and even vectors, and any other list inside it, and also functions are called as lists. So here, whenever we want to invoke the list function, so we make use of the function list. So here in the example, I have given it as list. One is the list name, then followed by the function list. So inside, I am giving the components, which all components will be in the list. Now the first three components are integer, then the next component is the float or the double, and the other one is the function. Sign is the function, mathematical function that is basically used. So this is how we are going to declare a list. So then coming to the matrix, now I will give you the demo of this in the later part of this session. Just now I'll be explaining about these basic objects of R programming. Then I'll give the demo of this, and then I'll go to the research part. Then matrix. Matrix is the two-dimensional data structure in R programming language. So when I say two-dimensional, it is 2 into 2 only. You can have two dimensionals only 2 dimensions. You cannot have multi-dimensions. For multi-dimensions, we make use of arrays. So it is a two-dimensional function, which is declared with the function called as matrix. So for example here, m is the variable name where we are going to store the matrix. So matrix, again we are making use of the component function, and we are adding the elements of the matrix, and we are providing the interpreter of R how many rows and how many columns to display. And we are displaying by row. That is, when I say by row true, then it displays it by row. That is 2 rows, 3 columns. Then the next object is array. As I've told you, whenever we want to make use of multi-dimensional array or matrix, we make use of array. So arrays are data objects which can store data in more than one dimension or more than 2 dimensions. An array is created using an array function. So A, here in the example, A is the array name where we are going to store the different items in different dimensions. So array, then again we are making use of seek function to store the elements of an array. So green, yellow, then dimensions. Here dim is nothing but we are giving the dimensions. What are the dimension of the matrix? So 3, 3, 2. Here 3, 3, 2 represents first row and then column, and how many times it will be displaying the array. 3, 3, 2 means 3 into 3 matrix, it is displaying 2 times with the elements of green and yellow. I'll just demonstrate it. Right now I am just giving you the explanation. Then coming to the factor. The factor is again one of the important objects of array, which is used to categorize the data and store it in different levels. They can store both strings and integers in the factors. So we can make use of function factor for factors. So here apple color is the factor. So here we are combining, apple color is a vector. First initially we are making use of vector called as apple colors. So in that we are having the elements, different colors of the apples. Then we are creating a vector called as factor apple with the help of the function factor, and its argument is the vector that we have already declared. So using this, it is going to display the different categories of the data. Then one more important thing that I want to have a glance is the data frame. Basically, data frame is a table or a two-dimensional array like structure in which each column contains value of one variable and each row contains a set of values from each column. Each column should contain same number of data items. That is very much necessary. You cannot have in one column, say for example, 4 elements, and in another column we can have 5 elements. No. So the basic requirement of data frame is that all the columns in your data frame should have same number of data items. So in the example here I have shown the example. Here I am trying to assess the body mass index of a person. So here I am making use of data frame. So in the data frame for gender, I am giving 3 items, that is male, male and female. For height, so these are my attributes, or you can say columns: gender, height, weight and age. These are my columns. So these will be having the same number of data items. You can see here all the columns have the same number of data items. So when I say gender, it has 3. When I say height, it has again 3 items. Then weight also 3 items, and similarly age also 3 items. So before going to the next part, then we also have something called as R functions. So basically we can use functions in the similar way as we are using in some other languages like C, C++ or Java. So the general syntax of function is function name followed by function that is the keyword. Then you can have, it is not compulsory, it is optional, that having the arguments in the function. So it is similar to, as I told you, it is similar to C, C++ or Java function. It is a built-in function. So for now I have given you an example of a built-in function, print mean 25:82. So here print is also a built-in function which prints the value of whatever the mean that is calculated. Mean is also a built-in function which is calculating the mean between 25 to 82 integer elements. Similarly, we can also have a user-defined function. So in the user-defined function, as everyone is almost aware of, it is defined by the user. So here we make use of new dot function. Whenever we are creating here a user function, we say it as new dot function, and the function that is the keyword followed by the parameter. Now here we are accepting the parameter from the user, that is new dot function 9 at the end, you can see. So what is that? That is the parameter A that is being fed to the function, and this parameter calculates the square of all the elements starting from 1 to 9. Similarly, I have one more function at the right side corner. New dot function is equal to function. Here we are not taking any parameters. Directly we are printing from 1 to 5 the the squares of the numbers. So simply we are calling the line as new dot function. So whenever this is executed, it will print the squares of all the 5 elements starting from 1 to 5. So at this point of time, I will switch to R programming. I'll just demonstrate whatever I have given you the explanation. Prashant sir, is it visible?
Sir, no sir. You have to share that.
Yeah, I'll share it. Is it visible now?
Yes sir, yes. Sir, can you increase the font size of those?
Yeah, I'll do it. I'll do that. Is it visible?
Yes, sir. Yes.
Is it visible right now?
Yes, sir. Yes.
Or shall I increase it some more?
Is it increasing, sir? I'm not finding any change much.
Just 1 second, sir. So is it visible now?
Yes, sir. Yes. Yes, sir.
So just now I have demonstrated all those basic things. So I'll start with a simple print now. Starting with the simple print now, when I execute this, so I'll just I have to select, or I just place a cursor here, and I have to say run. So when I say run here, so at the bottom you can say in the console that it is printing me hello world. That is what a simple basic thing. Now when I want to print the sum of two numbers, directly I can give it as print 2 plus 2. So when I say print 2 plus 2, at the bottom in the console you can just see that it is printing the sum. Similarly, I can store my hello world in one of the strings, and just I will call the string in to print. So here I'll just run this. So when I run this, so here my string. So now my string will contain this string called as hello world. So when I print it, it will print the hello world. Now creating a vector. Now just now I told you, for creating a vector we are making use of C function. That is, C is the component. We are adding the components to the vector. Apple is the vector. So in that we are going to add the colors of the different colors of the apple. So once we add it and then print it, we will come to know. Now I have created a vector called as apple. So when I print it, it will show me the elements of the vector. So as I've told you, vector is containing the similar types of elements. Now here it is the type is the string. So I've given the elements as string, that is red, green, and yellow. Now similarly, I am going to execute the list. I am going to execute the list function. So list one is my I am creating the list called as list one with the help of the function called as list, and I am adding the elements again with the help of C function. So when I execute this, so it says that at the console you can see a list is created. So when I print the list, it is showing me. I'll just show you. Just see. See, when I print the list, it is showing me the different types of elements that are stored in the list. So the first element, that is 253, that is stored in the first place, that is the integer type of element. Then in the second element is the floating point, that is 21.3. And the third one is the primitive sign function. So these are the functions, these are the elements of list. So whenever I want to store different types of elements in a form of vector, so list is the best thing to use. Similarly, now I'm going to create a matrix. Now here you can see the same example that whatever I have explained, I am using here. So when I execute this, a matrix M is created with 2 rows and 3 columns, and it is arranged by the row. So because I have given it that by row is equal to true. So if I give it as false, then it will take it by default. So when I print it, so just you can see 2 rows and 3 columns are displayed. Now whenever I want more than 2 dimensions to be stored, whenever I want 2 dimensions to be stored, then I make use of array. So here, creating an array, here A is my array that I am creating with the help of a function called as array, and the elements are green, yellow, and I am also providing the dimension with the help of again C, that is 3, 3, 2. As I've told you, 3, 3 is the size of the matrix, that is 3 into 3 matrix, and it will be displayed twice. It will be displayed twice. I'll just execute this. So when I execute this, I will just roll it. See, you can see here, it has displayed a 3 into 3 matrix with the elements of green and yellow. With the elements of green, yellow, that is, it is making use of the same elements to fill in the matrix. That is green, yellow, green. It is going on, and in the second time when it prints, so it will start over wherever it had left. In the previous this you can see here, this last was green, so it will be starting with the yellow. It will be starting with the yellow. This is about the matrix. Then coming to the factor. Now, for creating a factor, as I've told you, first we need to create a vector, and then we are going to display the factor. So here I am going to create a vector called as apple color. Again, that's what I'm just giving in the colors, different colors of the apple. So when I execute this, so it is creating a vector called as apple vector. Now the next thing that I'm going to do is I'm going to create a factor object. So factor object is my factor object is the factor apple. So it is going to display the factors, that is the elements of the vector. So when I execute this, so it has done, but I am not able to see it. Why? Because I have to print it. So when I say print, it will give me the different elements that are stored in the factor. So green, starting from green to red, to green again. Then the number of levels are 3. Why 3? Because we are having only 3 colors: green, red, and yellow. So if I change it to 4, my levels will become 4. So I'll just introduce one more color here. Blue, for example. I have introduced one more color here. So my number of levels in the factor becomes 4. So when I run this, so you can see here the number of levels are 4. It is displaying me as 4 levels. Then coming to the next one is creating a frame. So for creation of a frame, we make use of the function called as frame, data.frame. So data.frame means whatever the data that is available, it will be displaying. Data.frame, we have 4 different columns called as gender, height, weight, and age. So it will be displaying accordingly. I'll just execute this. Factor. Then I'll print the body mass index. So you can see here it is printing in the form of a table. That is the gender is the gender, height, weight, and age are the columns, and the rows are the different three different items that I have already put in. That is male, male, female, and their corresponding height and weight. So this was about the factor. That is, whenever I'm making use of factor, I want to display it in the form of table. I can make use of data factor. Then coming to the next, that is the built-in functions. So here I'm making use of two built-in functions here, print sequence. So when I say print sequence, SEQ is the sequence. Now sequence 32, 44 means it will print all the numbers between 32 and 44. So when I print it, so as you can see in the console, it is displaying all the numbers from starting from 32 to 44. So this is how I am going to display the sequence. Similarly, when I want to find out the mean between 25 to 82, elements 25 and 82, I'll just execute this. Then when I execute it, then it will show me the mean. Mean is the built-in function. Similarly, the sum between 41 to 68. Just this is just an example. And similarly, the user defined functions in R. So here, as I've told you, here we are making use of, we are taking an argument called as A. We are taking the argument of A. So whatever the user enters the value of A, that will be taken as the value in the for loop starting from 1 to A. So it will be printing the squares of that particular number. So when I execute this, you can see that it has executed the function, but still I haven't provided the argument. I need to provide the argument in order to display. So here in this, you can see here, I am just highlighting this new dot function. I am providing the argument called 9. So now it will print me the squares of all starting from 1 to 9. So you can see it is printing the values from 1 to 9. In the other example, now this is again a user defined function. It is a user defined function. Here we aren't providing any argument here. So I am directly I will be providing the values in the for loop itself. That is starting from 1 to 5, it will print the squares. So when I execute this, so again I need to call this function. Without calling this function, I cannot get the answer. So here just you can see here, it is printing the squares of all the values from 1 to 5, starting from 1 to 5. Oh, so this is about the basic function. Sir, is the PPT visible again?
No, sir. No, sir.
Okay. So I hope now it is visible, right?
Yes, sir. Yes.
Okay. Now the next one is, I'll just take a case study of ANOVA analysis. Now I'm jumping now after the basics. I'm jumping to the research part. Now I'm just taking the case study of an ANOVA analysis in R. So I hope everybody almost they know the word called as ANOVA. ANOVA is basically used for statistical analysis of two or more different groups. So ANOVA stands for analysis of variance. So it is basically used to compare the difference of means among two or more groups. So it is a statistical technique that is used to check if the means of two or more groups are significantly different to each other. It also checks the impact of one or more factor by comparing the means of different samples. So here we have two variations in ANOVA, that is one-way ANOVA and two-way ANOVA. So when I say one-way ANOVA, here when the name one way means we have one independent variable and one dependent variable. So using those two, we are trying to find whether they are significantly same or significantly different. So here we are going to find out the hypothesis, whether the hypothesis is near to the positive number or whether the hypothesis is near to the negative. Then we have the next one is two-way ANOVA. So when I said two-way ANOVA here, two-way ANOVA, as I've told you, one means we have one dependent variable and one independent variable. In two-way ANOVA, we have a factor of two independent variables which are compared against the one independent variable. That is, we call it as double testing. So here, before going to the analysis part, what are terms that are important here to remember? So as I've told you, I have already, I have just taken the words called as dependent variable, independent variable, and null hypothesis. So dependent variable, so analysis of variance must have a dependent variable that is continuous. This is our y. Its value will depend on the different levels of x or x's in the analysis. Then, as I told you, independent variable. Here, x is my independent variable. Now, if I want to give an example of any dependent and independent variable, so I'll give you an example of in water analysis, in water quality analysis, temperature is an independent variable. Whereas pH, dissolved oxygen, these are different parameters that are used for water quality monitoring. So I'm just giving you an example. So here temperature is the independent variable, and the pH, the dissolved oxygen, or the nitrate, these are the dependent variable which are dependent on temperature. As the temperature increases, the pH value should also increase. Then the DO value decreases, the nitrate also decreases. Similarly, when the temperature is low, the DO value increases, the nitrate also is increasing, and the pH value also decreases. So as I told you, temperature is independent of the other parameters, but the other parameters like pH, dissolved oxygen, and nitrate are dependent on the temperature. Then coming to the next, that is the null hypothesis. Null hypothesis tells us that whether all the means are equal. That is, we are trying to factor out whether whatever the assessment that I am doing is correct or not. So we have one more hypothesis called as alternative hypothesis. If null hypothesis is wrong, or if we are rejecting the null hypothesis, then we have to accept the alternative hypothesis. Then two more terms that are very much significant here is F statistics and P value. So F statistics is nothing but the F value and the F critical value. We have something called as F value and F critical value, in between which our data lies. So if the F critical value, if the F value crosses the F critical value, then definitely whatever the analysis that we are doing, it is not correct. Similarly, P value, P is the probability value. We always take error that is plus or minus 5% risk. That is nothing but 5% error. That is, P value always is indicated by 0.05. The default value for P is 0.05. That is 5% risk of including that differences exists. That is what? That is the errors that may be in the data. So here again we are assessing the P value. If P value is greater than 0.05, then we say that we can accept the null hypothesis. If it is below the 0.05 threshold, then we can say that alternative hypothesis can be used. That is, depending on the p-value, we can reject or accept the null hypothesis. Now I'm just going to give you the demonstration of this again in the R, demonstration of this ANOVA analysis. I'm just going to switch to again to R. Now I have written again. I have already written here. Already written the code here. I have written the code here. Just I will be explaining one by one. So here I'm trying to install the library. So now I require two libraries, DPL wire, that is DP layer, and ggplot2. So DP layer is basically used for ANOVA analysis, and the ggplot is basically used for graphical representation of whatever the result I am getting. Whatever the result I am getting. So here, I'll just start with this. I'm just loading the graphs. I'm loading the graphs. So once I'm loading, the loading is done, I'm basically using a data set of 48 items. Here, this is called as the poison.csv. Here, we are going to assess the different poisons that can be used for killing a rat, and the time taken for that rat to be treated. So I'll just demonstrate this here. I will just I will load the data. So once I've loaded the data, I'll just show you the data also. So here I have loaded the data here into my R library. Then I will show the glimpses of my data. So here the glimpses of my data is, you can see here. Here we have three columns: time, poison, and treat. So the time is the time taken for the poison to kill or react for the treatment. Then the poisons are of three types: type 1, type 2, and type 3. And treatment is again of three types: A, B, and C. So here, as I've told you, I have a 48 data items for my analysis. So here I am selecting the factor X. X is the poison. Now here I am making use of the X as the factor that I'll be making use of in order to analyze what are the different poisons, that is poison number 1, 2, or 3, how it is reacting, or how it is killing the rat. Then we are going to eliminate any duplicate data from the data set. That is called as here, that is, we are mutating it. Then here the next part here is I am grouping it by poison. I am arranging, that is, now I am ordering the elements of my table with the help of the poison, grouped by poison. Poison is nothing but it is the attribute, or you can say the column. So I am going to group it by the poison. So when I execute this, so it is giving me, I'll just show this. When I execute this, it is summarizing, that is ungrouping the output, overriding the group arguments depending on the poison. My poison becomes the first attribute, then the count of poison. So as I've told you, there are 3 different types of poison. Each poison is of the item, data item that is representing the poison is 16. So 16 into 3 is 48 items that I have already told you. So here I am also calculating the mean time and the standard deviation. The mean time and the standard deviation time of the poison that is reacting. So the mean time for the reaction of poison number 1 is 0.618. Similarly, for 2 is 0.54, and for the third one is 0.28. So this is the mean time in which it is going to react. Then the standard deviation is here it is 0.209, 289 and 262. Sorry, 0.062. So here we have done with the mean time and the standard deviation of the poison. Now next one that I'm going to represent is, I'm going to plot a graph. I'm going to plot a graph in order to see how scattered are the data of all the 3 different types of poisons. I'm just executing this plot. So I'll just zoom in this. So is it visible? The graph is visible? Sir, is the graph visible?
Yes, sir. Yes, it is visible, sir.
Okay. Okay. So here you can see the reaction time of all the different poisons with the standard deviation and the mean time, and how the data here, these points, dotted blue points shows that how the data is scattered for all these poisons. So here, as I've told you, the mean time for poison 1 is see 0.6 is 0.6. So you can see here when I say 0.6, here the black line, in the black line here, it represents 0.6. Similarly for the other 2 poisons also. So it is depicting the mean of the reaction time for all the 3 different poisons. Then the next one is, now I'm going to the ANOVA part. So this is about the graphics. I'm just depicting the simple graphics here. So now here I'm going to the ANOVA part. So here, whenever I'm trying to assess the ANOVA analysis, I am going to use the function called as AOV, analysis of variance. Analysis of variance. What are my factors? Now, as I've told you, I'm making use of here. As you can see here, sorry. As you can see here, ANOVA one way. One way means here I have one independent variable along with one dependent variable. So here my time is the x, that is the independent variable, and poison is the dependent variable, which is dependent on the time. So the time taken for the poison to kill, or the time taken now in the next part, I can also make use of the time taken for the treatment given to the rat in order to fight against the poison. So similarly, something like that. So here we have 2 factors, one factor, that is one independent variable, that is the time, and one is dependent variable, that is the poison. So we are making use of the data set that is we have already created of 48 data items. So when I execute this, it will show me the analysis. That is, until and unless I show, it will execute the ANOVA analysis, but it is not showing me the analysis. So for the view of this analysis, I want to make use of one more function, built-in function called as summary. So when I say summary of ANOVA one way, then it will show me what are the what are the findings of ANOVA. So here, as I've told you, F value, F statistics, and P value. So these are the two important factors by which we can assess whether to reject the hypothesis or to accept the hypothesis. Here the hypothesis is, here I've just written here, I forgot to tell you, I'll just show this. I've just written here, my H0, here H0 is the hypothesis that tells that there is no difference in the survival time of survival average time between the groups, and the alternative hypothesis is the survival time average is different for at least one group. So this is how I am going to differentiate between the hypothesis and the alternative hypothesis. So whether I have to accept the hypothesis, null hypothesis, or I have to reject the hypothesis, that is how I am going to predict. So here, as I've told you, F value and P value. F value, that is F statistics, and P. These are the two values by which I am going to predict whether I have to accept the hypothesis, null hypothesis, or to reject the null hypothesis. So here, as you can see that here the P value is 7.66 e raised to minus 0.5. When I say minus 0.5, it is much smaller than the P value. Now, P value that we have considered, I have already told you, that is 0.05. Whenever that is the threshold. So if the P value, that whatever the P value that I have calculated from the ANOVA analysis, if it is less than 0.05, then definitely I am going to reject the hypothesis and I am going to accept the alternate hypothesis. So from this we can say that we are going to reject the null hypothesis, saying that all the poisons have the same time of killing. No. By this we can disprove that, that is, each poison has its own time of killing. So by this I can say that my null hypothesis is rejected, so I have to accept the alternate hypothesis. So here you can see that here we have 3 stars, then 2 stars, and a star and a dot. So here this will tell us whether we have to reject or to accept the null hypothesis again. So here for this poison we have a 3 star. 3 star means it is less than 0.001, which is less than 0.05. So by this we can say that we are going to reject the null hypothesis. So this is using one-way ANOVA, that is, we are making use of one independent variable and one dependent variable. Similarly, I'm just going to switch to the next part, that is the ANOVA, two-way ANOVA. So here, two-way ANOVA means, as I've already told you, we have one independent variable and we have 2 dependent variables. Here, these are the 2 dependent variables, that is treatment and the poison. These are the 2 dependent variables which I am going to test against the time. Here, before testing, I shall just tell you what will be the hypothesis, null hypothesis, that is H0 and HA. So here, the means, my H0, that is the null hypothesis, tells me that here my null hypothesis tells that the means are equal for both variables, that is the factor variables. And my alternative hypothesis says that the means are different for both the variables. So I have to prove that the means for the poison as well as treatment is same. If it is same, then I am going to accept the null hypothesis. If it is not same, then again I have to accept the alternate hypothesis. So I am just going to execute this. So here I am going to execute this two-way ANOVA. As I have told you, I have one independent variable, that is time, and the two dependent variables, poison as well as treat. So using this, I am going to find out whether the means of the two factors, that is the poison and the treat, are same or not. So here I have executed the two-way ANOVA. I'll just summarize what is done here. So here you can see that. Here you can see that, just see, in the similar terms, here both the poison and the treatment, it is giving me triple star. When it is triple star, it tells us that the p-value is less than the threshold value of 0.05. It is more or less than 0.001. As the significant codes, you can just see here the significant codes tells us what are these. So it tells that it is less than 0. That is, triple star tells me that it is less than the threshold value. So by this we can say that the p-value of poison as well as the p-value of treat is less than 0.05. As a result, what we need to do, are we accepting the null hypothesis or are we accepting the alternative hypothesis? Can anybody tell me? Can just anybody tell me, are we accepting the null hypothesis or are we accepting the alternative hypothesis?
Sir,
Yes,
they are putting in the chat box.
definitely. I got it.
Okay.
Yeah. We are rejecting the null hypothesis and we are accepting the alternative hypothesis. Yes. So this is how we can have the analysis. So you can see we only have two functions. Using two functions, we can have the analysis of ANOVA easily in the R. Then similarly, I am just going to find out the what is the difference between the means of the factors using 2K HSD. 2K HSD stands for, it is a person called as 2K, John 2K, who has given this formula for honest significant difference between the sample means. That is, when I am using two different samples, definitely it will give me the honest significant difference. So when I run this, so here it is giving me here, just see, it is a 2K multiple. Now here it is telling me that it is 95%. That is 5% plus or minus errors are there in the data. So here it is going to compare the two poisons. That is, here you can see here two poisons are being compared. That is, one is compared with 2, one is compared with 3, and 2 is compared with 3. So whichever has the P adjacent which is greater than 0.5, we can say that these two, that is poison 1 and 2, have a 2K HSD. That is the honest significant difference. We have a honest significant difference. Otherwise, if we see 3.1 and 3.2, the P value is less than 0.05. So because of that, we are again going to, we are not going to make use of this. So we are making use of the P adjusted value of 1 and 2. Then similarly for treatment, again here, treatment you can see that almost these first four can be used as an alternative treatment, either A or B. either A or sorry. Just 1 second. It is upper and the lower layer. Here P adjusted. Sorry. Here you can see that this and the that is CA, DB and DC can be used, and also DA can be used for as an alternative treatment again between C or A, or again that is what treatment are of 4 types: treatment A, treatment B, treatment C, and treatment D. So here adjusted tells that if we are taking poison, any of the poison that if we are taking the if we are treating a particular rat, we can either use C treatment or A treatment. Similarly, we can use D treatment or A treatment, and so on. So now here one more thing I need to plot. I'll just show you the plot of one-way ANOVA and two-way ANOVA. So here just 1 second, I'll just minimize the font size. Because of that, it is not able to show the I'll make it 150%. So here you can see that items number 42, 14, and 20. These are the values which are disrupting the null hypothesis. Because of these three values, because these are very far away from the linear line that we are drawing, you can see that all the other points are almost on the line except for these three. 42, 14, and 20, these are very far. Because of these, we are not able to accept the null hypothesis. We are not able to accept the null hypothesis for one-way ANOVA, that is for time and poison. Similarly, when I execute the two-way ANOVA here, now again I'll just zoom it in. So again, these are the three parameters because of which again there is a rejection of null hypothesis. That is, we are going to reject the null hypothesis. So using this plot, we can see that again, these are the three data items which are affecting our analysis, because of which we are forced to reject our null hypothesis. This is how we are going to use the R programming in the research. Now this was my hello. ANOVA was my part of one of my research work. So I have just chosen ANOVA for this webinar. Thank you. Sir? Hello, sir? Hello? So this is what about the webinar that is about the research. You can make research in neural networks I'll just show you one more. Just give me a second. I'll just show you one more. Just. Uh, so here I'm making use of ANOVA. Sorry, no, not ANOVA. Sorry. I'm making use of artificial neural network. Here also again neural network for my research work. I'm just showing you this. This is how now using this library neural network, we can make use of machine learning libraries available in R. So when I execute this, definitely I will get whatever the results that I'm interested in. So this is there are many different packages again. So here you can see these packages. Here you can see different packages available. So you can select whatever the packages you want accordingly, and you can make use of these packages for your research work. Thank you. Hello, sir. Patwadan, sir. Hello. Hello, sir. Hello. 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 Am I audible here? Hello. Hello.
Yes, sir. You are audible.
Okay. Okay. This is about the ANOVA analysis. Hello. Hello. Hello, Patwadan, sir. Hello.
Sir? Sir, sorry.
Sir.
Washroom ಹೋಗಿದ್ದೇನೆ ನಾನು.
Okay. Sir, I have just done with my presentation. If
Sir, there are some questions I think I'll ask them to unmute and ask you.
Yeah.
Participants, if you have any queries regarding this session, please unmute yourself and ask sir. You can unmute yourself.
Sir.
Yes. Hello. Good afternoon.
Sir, this is good afternoon, sir. This is Srinivas.
Yeah.
Sir, I have a question. You have given very nice informative session.
Yeah.
I have a question regarding R, adjusted R square and R square. What is the difference between R square and adjusted R square?
Okay, sir. So R square is basically the variation of proportion in the dependent variable. That is how dependent variable is fully dependent on the independent variable or not. That we can adjust with the help of R square. And if it is not, we are going to adjust it in order to make it compatible with the independent variable. That we call it as R square and adjusted R square, sir.
Sir, there is one query in the chat box, sir.
Okay.
Soumya R.
Okay, wait, sir, I'll just see it. I'll just see it. Okay, she is asking me about how it is possible to print in one statement, only in one statement, whereas we use in C language we are making use of a whole lot of steps in order to do that. That is the beauty of our programming. That is, we have the inbuilt functions that are already available. So using that inbuilt functions within a one line, we can execute our analysis. Similarly, that's what I've told you. I can make use of, I can execute my artificial neural network within one line only. That is the beauty of the R. That is, it provides a large, rich set of libraries using which we can easily arrive at the results.
Hello, good evening, sir.
Yes, sir.
Yes, sir. Is it the data structure of R tool is same as C structure?
Yes, sir. You can find it similar to RC.
Okay. Any difference, sir?
Sir, any difference means, as I've told you, you can directly make use of functions, built-in functions that will enable you to execute your program within one line. Whereas some of the data structures of C are inherited in R also. That's what I told you. You can use the loops. You can use all the different data structures. That is integer, double, string. All these can be used as same as C or C++ or Java.
Sir, one more question is there in the chat box.
Definitely, one of you have asked me that you are using NS2 and you will be. Is it possible to use AWK files of NS2 to plot graphs in AR? Yes, definitely you can use it. But right now, I don't have idea about how do we do that AWK. So if you give me some time, or if you share me your email ID, I shall get back it to you. How can we use AWK files in NS2? Because R is a highly compatible language. That is what I've told you. Any code can be used in R programming in order to execute. So any other queries?
Sir, Karthik Rao wants some question. I think, I don't know. Can you repeat again?
I have just. That's what I have just told him. That is, he's doing some PhD.
No, not regarding this AWK files. I think he's asking about the R square and adjacent R.
So that's what I told you. So when I say R square is nothing but how the values of dependent variable are compatible with the independent variable. So that is given by R. If they are not at all compatible, then we adjust it by minimizing the errors. That we call it as R adjusted square. That I have already answered, I guess.
Yeah. Sir,
Any
there is
other
one more question in the chat box.
Yes, in what way are tools will be useful for network security domain? Sir, I have to explore the network security because my research avenue is data analytics. I don't right now. I don't have any idea about network security using R tools. So give me some time. I'll just come back to you. You can share your email. I'll just contact you. because my research area is analytics. So I don't have any idea about network security.
Sir, can you share your email ID in the chat box so that they
Yes,
will
yes, yes,
send?
yes. I'll do that. So this is my email ID. You can contact me at this email ID, and my number is 9886. So this is my number. So you can either ping me or you can just call me.
Sir, there is one more question in the this thing.
I'm not getting that course. Course.
No, there is one Professor Satyanarayana Padaganur is asking how can we learn R tool quickly?
Sir, I have quickly means that's what I told you, the basics. So using those basics only, if you can go on expanding your library of your vocabulary or something like that, definitely you can learn it within a month. Definitely, sir. I can assure you. So many YouTube you can see many in the YouTube many courses are available. You can take that. It is those are very fantastic courses that are available. So or you can use the best friend is the textbook, the books. If you see the book, if you can go through the books, definitely you will be able to learn it much quicker than whatever.
I think Coursera and Udemy courses are
Yes,
also
yes,
there, no,
definitely,
sir?
sir. Definitely, sir. Definitely. Coursera and Udemy are the best courses they are providing on R as well as machine learning.
Sir, asking for a website available for this R tool.
Sir, it is an open source. You can just go to the Google and you can type just R. You will get the whole bunch of things in the Google.
So will you share the PPT and the codes what you have
Yes, yes,
given the
yes,
demo today?
definitely. I'll mail to you, sir. You can just
Yeah, I'll
you
put it
can
in the
share it with
Google
them.
Drive and I'll share the link with them.
Yes, sir. Definitely, sir.
Yes, sir.
Thank you, sir.
Sir, shall we close it now?
Yeah, sir.
Okay, I'll conclude.
Sir,
Yeah.
sir, can you send for us an email to inform us about any training like that about our programming?
Yeah. You can use Coursera or Udemy courses. These are best courses.
I used Udemy and I'm studying MSc IT. I'm studying R programming, but I want to know what's the machinism to follow the rules. I know the basics and I know the general idea, but
Okay.
I want to be master on this program. So I want advice.
Yes, then the best thing that you can do is use the data science R using R. I'll just share the textbooks also. I'll just share the
Please, sir.
textbooks also. You can go through them.
Okay, sir. Thank you. On the email, on our email.
I'll just share with Patwardhan sir, and he will be sharing with you.
Okay, sir. Thank you. Thank you so much.
Yeah. Thank you.
Hello. Sir, there is a query from Karthik Rao.
Okay, sir.
There are a lot many courses in the Udemy. So which one to choose?
So sir, if you are well versed with basics, then definitely go for the next level courses. If you aren't well versed with the basics, then start with the basics and then you can go in sequence one after the other.
Okay. So I'll just propose a vote of thanks, sir. Thank you very much, sir, for the wonderful session. Starting from the fundamentals of using how to use the R tool and then reaching to the igniting the research mind with the R tool. Hope all the participants have benefited from this and they make use of this for their research work. If they have any queries, definitely they are going to ping you. And thank you very much, sir, for the wonderful session this afternoon.
Thank you. Thank you. Thank you.
Yeah. Participants have shared the link for the feedback. Please fill that feedback for the session 3 of day 5. And after that, in another 10 minutes, we will be closing it down, signing it off. And tomorrow at 9:30, we are going to start with IoT and machine learning by industry person.
So Prashant sir, thank you. Thank you very much.
Yes, sir. Thank you very much, sir, for your time. You are at home or hello?
Sir, I am in the college because network problem, so I came to college only.
Okay. I heard that you people are getting enjoying holiday.
Yeah, we are enjoying, but for this session, definitely I had to come.
Okay.
Because at my place, I don't have the network problem. I have a network problem.
Okay. Otherwise, also there may be now. I think it's heavily raining. I heard.
I have to see, sir. I have seen.
And power also, the power cut also will be there.
Yeah, definitely, sir. From last 2 days at least, there was no rains.
Okay.
Okay, sir.
Okay, yeah, you can sign off, sir.
Thank you,
for
sir.
another 10 minutes and I'll close.
Yeah.
End the meeting.
Thank you, sir. Thank you for giving me this opportunity.
No, sir, it was wonderful, and I felt it very good at this stage for all the researchers.
No, sir. That's what, sir. It is like you people who have encouraged us, sir. Nothing like that. So if you give us encouragement, definitely it will be a good thing.
No, sir, it's okay. Thank you.
Yes, sir. Thank you, sir. Thank you.
Yeah, chalo. Okay, bye.
Bye, sir. Bye.
Bye. Good day.